Hello everyone, in this video we're going to review AP Precalculus Unit 2 Exponential Logarithmic Functions. Alright, we're going to talk about the arithmetic and geometric sequence. Topic 2.1. Now we have arithmetic sequence formula. It could be a sub n equals a sub k plus common difference times n minus k. Whereas a sub n is could be n terms. A sub k is could be k term. Okay, k always less than n. Now here's the hint. You need to find the common difference using the slope formula. Now for geometric sequence, g sub n equals g sub k times r raised to the n minus k, where r is the common ratio, r the multiplier. Alright. Now here's the hint. You need to plug both points into the formula to find the common ratio. Now let's take a look at the examples below. For question 1 to 3, use the information below to write an equation for the following arithmetic sequence. Then find the 11th term of the sequence. Alright, so you have the 4 terms and the 9 terms right here. Now you can treat 4 terms as the k terms and the a sub 9 right here as a 9 term. Alright, so we're going to use the formula right here. So we have equals a sub k, which means a sub 4, right? Plus the common difference, we don't know it, we put d, right? Now k equals 4, n equals 9, right? So it could be 9 minus 4. Alright, now I substitute values. Negative 3 equals 7 plus d times 5, right? Now I'm gonna subtract 7 both sides. So I have 5d equals negative 10, right? So d equals negative 2, right? Now I need to find the 11th term, right? So I need to substitute d equals negative 2 back to this formula right here, right? So I have a sub n equals a sub k. Now in this situation you can pick any of this guy right here as an k terms, right? You either pick this one as an k terms or this one as an k term, right? So I'm gonna pick this one. So a sub k, which means 7 minus 2 times n minus k, which means 4. Alright, now I need to solve for 11 terms. So I substitute 11 for n, right? So I'm going to end up with a sub 11 equals 7 minus 2 times 11 minus 4, right? 11 minus 4 is going to be 7. 7 times 2 is going to be 14, right? So 7 minus 14 is going to be negative 7, right? Now let's move on to question number 2. Alright, so the common difference is given, right? So we have a sub n equals a sub k, which means a sub 2 right here. It's going to be 5, right? Plus the common difference is going to be 3 times n minus k. K in this situation is going to be 2 right here, right? Alright, now I need to solve for 11 terms, right? So I have a sub 11 equals 5 plus 3 times 11 minus 2, right? So 11 minus 2, it could be 9. 9 times 3, it could be 27 plus 5, it could be 32. So a sub 11 equals 32, right? Now, question number 3. Now we need to find the common difference d, which is the slope of the line passing through these points, right? So you just use rise over run, right? Going down by 1, so it could be negative 1. Go to the right by 2, it could be 2. So the slope is negative 1/2, right? That is the common difference, right? Now I have a sub n, equals a sub k. You can pick any points right here, right? So I can pick this point. A sub k equals 7, where k equals 1 right here, right? So it can be 7 plus common difference. Common difference is going to be negative 1 half right here, right? So negative 1 half times n minus 1, right? Because I picked the first term right here, right? A sub 1. Now, I need to solve for a sub 11, right? So I have a sub 11 is going to be 7 minus 1 half times 11 minus 1, right? 11 minus 1 is going to be 10. 10 divided by 2 is going to be 5. So 7 subtract 5 is going to be 2, right? Now let's move on to the next one. For question 4 to set, use the information below to write an equation for the following geometric sequence. Then find the a term of the sequence. Alright. Now this is the geometric sequence, right? So we know that the formula is going to be g sub n equals g sub k times common ratio raised to the n minus k, right? So you can use g sub 3 as g sub k, right? And g sub z as g sub n, right? Now we substitute over here, we need to find the common ratio, right? So I have 1.5 equals 12 times common ratio 6 subtract 3, right? So we're going to divide both sides by 12. So 1.5 divided by 12 is going to be 1 over 8 equals r raised to the third, right? We need to solve for r, right? So we're going to take cube root both sides. So r equals 1 half, right? Now we need to solve for g sub 8 equals. Now within these two terms right here, you can pick any terms as an g sub k, right? So I pick this one. It's going to be g sub 3 times common ratio is going to be 1 half raised to the 8 minus 3, right? Now g sub 3 equals 12, so I put 12 here, right? Alright, so it's going to be 12 times 1 half power of 5, right? So it's going to be 12 divided by 32. And if you simplify, divide the top bottom by 4. So it could be 3 over 8, right? Now question number 5 is similar to question number 4. I'm going to leave this one for you to practice. The answer must be 384 for the terms g sub 8. Alright, now question number 6. Look at the graph right here. We need to find the common ratio. Alright, we see that the first term right here has the value 6, right? The second term right here has the values 3, right? So we need to find the common ratio by taking 3 divided by 6, right? It's going to be 1 half, right? So now we need to find g sub 8 is going to be the first term right here. It could be g sub 1 times 1 half 8 minus 1, right? Now g sub 1 is going to be 6, right? Value 6 right here. So I put 6 right here. So it can be 6 over 2 power 7, right? So it's going to be 6 over 128. Now if you divide the top bottom by 2, it's going to be 3 over 64, right? Now let's move on to the number 7, the word problem. Scientists are studying the growth of a particular bacterial colony in a laboratory. The population of the bacterial colony can be modeled using geometric sequence, where the first day of the study is day 1. The population on day 5 was 7,000 bacteria, and the population on day 8 was 32,000 bacteria. What was the population of the bacterial colony on day 7 based on the model? Alright, so here is the key information. This is a geometric sequence, right? So we have g sub n equals g sub k times common ratio raised to the n minus k, right? Now the k term, which means the fifth day right here, right? So you have 5,7,000, right? Now the n term is going to be day 8 right here, right? So it's going to be 8,32,000, right? So we use this point right here, substitute into this formula to find the common ratio, right? So this one represents g sub n, this one represents g sub k, right? So I have 32,000 equals 7,000 times common ratio raised to the 8 minus 5, right? I'm going to divide both sides by 7,000, so r raised to the 8 minus 5 is going to be 3 equals 32 over 7, right? Now I need to eliminate power 3 right here, so I need to raise to the 1/3 both sides, right? So the left hand side should be power of 1/3, the right hand side should be power of 1/3, right? So it turns out to be r equals 32 over 7 power of 1/3, right? Now we need to estimate the population of the bacterial colony on day 7, right? So we're going to use this formula again. So we have g sub 7 equals g sub k. We can pick the fifth day as a g sub k, right? So I have g sub 5 times common ratio, which means 32 over 7 power of 1/3 raised to the n minus k, right? So raised to the n in this situation, which means 7, right? Minus k, which means 5, right? Like that. Alright. Now g sub 5 equals 7,000, so I put 7,000 right here, right? Alright, so I simplify this one, so g sub 7 is going to be 7,000 times 32 over 7 raised to the third, right? Now I'm going to put this one on the calculator, right? So I hit add calculator here. It's going to be 7,000 times, and then the answer right here. Now you want to convert this one to decimal. You just hit menu number right here, convert to decimal, hit enter. So the answer should be question number 8. This is similar to question number 7. The only thing difference right here is the arithmetic sequence right here, right? After 7 minutes, there were 46 people in line, right? So we have 6, 46, right? Now, after 15 minutes, there were 134 people, right? So we have 15, 134, right? Now, question, how many people will be in the line after 19 minutes, right? So we have 19 minutes right here, question mark, right? Now, because it's an arithmetic sequence, so the formula is going to be a sub n equals a sub k plus common difference n minus k, right? We can use this one as a sub k, right? And this one as a sub n to find the common difference, right? So we have 134 equals 46 plus d times 15 subtract 7, right? Alright, so we need to subtract 46 both sides. So it turns out to be 88 equals d times 8, right? So divide both sides by 8, so d equals 11, right? Now we have a sub 19 equals a sub k. We can use this one as a sub k, right? It's going to be 46 plus common difference. It's going to be 11 times 19 subtract 7, right? So it's going to be 46 plus 11 times 12, right? So it could be 46 plus 132, right? So it could be 178. Now let's move on to the next topic, exponential function topic 2.3 to 2.5. Now we have the general form of the exponential function. It could be y equals b raised to the s, right? Now if b greater than 1, this is exponential growth, right? Now you look at the one inside parenthesis right here, b equal 2 is greater than 1, is exponential growth. Now if a is negative, right, there is a reflection about the x-axis, right? Now this one right here, exponential decay, because b greater than 0 less than 1, right? b equals 1 half right here, right? So this is exponential decay, right? If a is negative, there is a reflection about the x-axis, right? So it could be like this. Now keep in mind, this function is concave up. If you see something like this, half of this one like this, the function is concave up, right? Now if you see something like this, half of this one is going to be like this, the function is concave down, right? The function is concave up, the rate of change is increasing. The function concave down, the rate of change is decreasing. So keep that in mind. Alright, now let's take a look at the first example, example number 9 right here. The graph of the function f is shown above. Which of the following could be an expression for the function f? Alright, now we know that the function f is decreasing, right? This is the decay function, right? So b must be greater than 0, less than 1, right? Because it's going to be right here, right? So we're going to eliminate a, right? Now look at b right here. There is a negative sign in front of a, right? So there should be a reflection over the x-axis, so it should be something like this, right? So we need to eliminate b, right? Now look at d, there is a reflection, so we need to eliminate d, right? Only c is correct, right? Now we can use the y-intercept to check, right? So y-intercept right here is going to be 0, 2, right? So we substitute 0 for s in this situation. The answer must be 2, right? So we get f of 0 equals 2 times 1/3 power of 0. It's going to be 2 times 1, right? Because 1/3 power of 0 equals 1, right? So it could be 2, right? So the y-intercept is 2. So the answer must be C. Now let's move on to question number 10. The exponential function g is defined by g of s equals a times b to the s, where a and b are positive constants. The table gives values of g of s at selected values of s. Which of the following statements is true? Alright. Now we look at the table right here. We see that in order to get 24 from 72, I'm going to multiply by 1/3, right? Now to get 8 from 24, I'm going to multiply by 1/3. To get 8 over 3 from 8, I'm going to multiply by 1/3. And this guy multiply by 1/3. Now look at the input value right here. You see that the input values increasing by 1 each time, right? The outputs over consecutive equivalent input value intervals are proportional, right? So this is an exponential function, right? Now, since the common ratio is less than 1, right? So this is the exponential decay function, right? So the answer must be A, right? Because b greater than 0, less than 1, right? Now let's move on to question number 11. Which of the following exponential functions demonstrates exponential growth, which means b greater than 1, right? And a must be positive, right? Now, this one b less than 1, so this is wrong. This one a is negative, so this one wrong. This one b greater than 1, right? So this could be right. Now this is a less than 1, so this is wrong. The answer must be C. Now look at question number 12. The end behavior of an exponential function h is described by the limit statements above. So this one right here. Which of the following could be the function of h of s, right? Now from this given information, we can sketch a simple graph of this one, right? So when it comes to end behavior, you're going to put negative on the left hand side of the x-axis, positive right here, positive here, and negative here, right? Now, limit of the function h of s when s approaches negative infinity, right? So when s goes to the left, the function going down, right? Because it's negative infinity, so it should be something like this, right? Negative, negative. Now, limit of the function h of s when s approaches positive infinity. So when s goes to the right, the function approaches 0, which means it's close to the x-axis. So it could be something like this. Alright, so we see that this is exponential decay function and there is a reflection, right? So because exponential decay function, the value of b must be less than 1 and greater than 0, right? So I need to eliminate b and c, right? Now I look at this one, there is a reflection, a must be negative, right? So I need to eliminate a, the answer must be D. Now let's move on to question number 13. The exponential function k is defined by k of s equals 5 times 2 over 7 to the s. Which of the following statements about the function k is correct? Alright, so we know that b greater than 0, less than 1, right? So it's going to be exponential decay function. And the y-intercept is 5, right? So we're going to sketch the graph of this one. So it's going to be something like this. This is the y-intercept 0, 5, right? Now k is increasing. No, k is decreasing because the rate of change is negative, right? If you draw the tangent line of this guy, right, the rate of change is negative. Keep in mind, you have the Christmas tree trick. The rate of change positive is going to be something like this. The rate of change negative is going down like this. Rate of change is 0, it's going to be horizontal line. Rate of change is undefined, it's going to be vertical line right here. Alright, now, so this is decreasing, so this is wrong. K is increasing, this is wrong. K is decreasing, right? So C and D could be right? And the graph of K is concave up. Yes, it's concave up, so the answer must be C, right? Now let's move on to question number 14. Selected values of the function f are shown in the table above. Which of the following claim and explanation statements best fits this data, right? Now from the table, we see that the s values is increasing by 1 each time, right? So this is the equivalent of input intervals, right? Now look at the output. Each time you're going to multiply by 4, right? So the outputs over consecutive equivalent input value intervals are proportional. The answer must be C, right? Now let's move on to question number 15. Which of the following functions is an equivalent form of the function y equals 4 raised to the 3s, right? Now, this is actually exponential manipulation, right? So, you just manipulate this one, right? So, I have y equals 4 raised to the 3s, so I just write y equals 4 raised to the 3rd, and then raised to the s like that, right? Remember, you learned from algebra 1, a raised to the m times n can be written as a raised to the m all together raised to the n, right? Now, 4 raised to the 3rd is going to be 64, right? So 64 raised to the s, the answer must be C. Now, question 16. which of the following functions is an equivalent form of the function y equals 9 times 4 raised to the s, right? And this question similar to question number 15, right? We just manipulate this one, right? So we have y equals 9 times. Now 4 can be written as 2 power of 2 all together power of s, right? So it's going to be 9 times 2 power of 2 s, right? So the answer must be C. Topic 2.32, 2.9 Exponential and Logarithmic Functions. Alright, question 1. Which of the following functions is an equivalent form of the function y equals 3 raised to the s plus 3? Alright, so we just manipulate this one. It's going to be 3 power of s times 3 power of 3, right? And it's going to be 27 times 3 power of s, right? And the answer must be D. Now question 2. f of s equals 4 raised to the s minus 2. So it's going to be 4 raised to the s over 4 squared, right? So it could be 1 over 16 times 4 to the s, right? So the answer must be D. Now question 3. The function g of s equals 16 times 9 to the s. We need to manipulate this one. So it's going to be 16 times 3 squared raised to the s, right? So it's going to be 16 times 3 raised to the 2s. So the answer must be D, right? Now question 4. h of s equals 25 times 36 to the s. Alright, so we just manipulate this one. It's going to be 25 times 6 squared all together raised to the s. And it turns out to be 25 times 6 raised to the 2s, right? So the answer must be D. Number 5. K of s equals 9 times 4 to the s. It's going to be 9 times 4 can be written as 16 raised to the 1 half, right? All together raised to the s, right? So it's going to be 9 times 16 raised to the 1 half s, or 9 times 16 raised to the s over 2, right? So the answer must be C. Number 6. f of s equals 16 times 4 to the s. Now this one can be written as 4 squared times 4 to the s, right? And it's going to be 4 squared plus s, right? So the answer must be B. Next one, the exponential function g is defined by g of s equals negative 2 times e to the s, right? Which of the following pairs of statements correctly describes the end behavior of g? Alright, so we need to sketch this one, right? Now we know that y equals 2 times e to the s is an exponential growth function. Alright, so it's going to be something like this. Now, since you have the negative side in front of the coefficient 2, then there is a reflection over the x-axis. So it's going to be something like this. Now, answer choice A. Limit of the function g of s when s approaches negative infinity equals negative infinity. No. When s approaches negative infinity, the function approaches 0, right? Which is the x-axis, right? So this one should be 0. Limit of the function g of s when s approaches positive infinity equals negative infinity, right? This guy go to the right, this guy go down. You see that? So this guy should be negative infinity. Question B. limit of the function g of s when s approaches negative infinity equals positive infinity. No, it's gonna be 0, right? The x-axis. Limit of the function g of s when s approaches positive infinity is negative infinity, right? So this one is negative infinity. Answer choice C, limit of the function g of s when s approaches negative infinity equals 0. Yes, that's correct. Limit of the function g of s when s approaches positive infinity equals negative infinity. Yes, that's correct. So the answer must be C. Now, question 8. Similar to question 7, right? Given the graph right here, we need to find the end behavior, right? Now, answer choice 8. Limit of the function f of s when s approaches negative infinity, right? Negative infinity right here. The function approaches positive infinity, right? S go to the left, the function go up, right? So this wrong, right? Because it says negative infinity. Answer choice B. Limit of the function f of s when s approaches negative infinity equals positive infinity. Yes, that's correct. Limit of the function f of s when s approaches positive infinity is approaches x-axis which is 0, right? So it's B. Now question 9. Given the graph right here. Question. Which of the following could be an expression for the function k right here? The exponential function has the form of f of s equals a times b raised to the s, right? Since the function reflects over the x-axis, so a must be negative, right? So a less than 0. And this is actually exponential growth function, right? It's gonna be something like this, and then it's gonna reflect over the x-axis, right? So b must be greater than 1, right? Now look for the answer right here. A could be right? B is wrong, right? Because a must be negative, right? C is wrong. D could be right? Now since this is exponential growth function, b must be greater than 1, right? So the answer D is wrong, right? So only A correct. Now question number 10. The exponential function h decreases at an increasing rate. Most of students struggling with this question. Now you need to split this one into two statements, right? The first one, the function h decreasing, right? So if the function h decreasing is going down like this, right? Now the function h is decreasing at an increasing rate, which means the rate of change is increasing. So if you draw two tangent lines, you will see it. The rate of change is getting bigger and bigger, right? Because if you use the Christmas tree trick, the rate of change is negative, it's gonna be this guy right here, right? And then if the tangent lines getting less steep, the rate of change is bigger, right? So in this situation, A must be positive, right? Because the exponential decay function has the form of this one, right? So A greater than 0, B greater than 0 but less than 1, right? So we need to eliminate A, B, and D, right? The answer must be C, because there is no reflection over the x-axis, right? Now question 11. The exponential function f is defined by f of s equals a times b to the s, where a and b are positive constants. The table gives value of f of s at selected values of s. Which of the following statement is true? Alright, so we look at this one right here. We need to find the change in s, right? So we know that every single time the value of s increasing by 1, right? And the y values are proportional with a common ratio 2, right? So the outputs over consecutive equivalent input value intervals are proportional, right? So this is an exponential growth function. The answer must be D. Because A positive and B greater than 1, right? B in this situation is 2. Now question 12, similar to question 11, right? The common ratio is 10, right? Which is B equals 10, right? So you need to eliminate A because B less than 1. Eliminate C, B less than 1. Only B and D correct, right? Now because B greater than 1, it's going to be exponential growth, right? This is not the case, so B is wrong. The answer must be D. Now number 13, the exponential function h is divided by h of s equals 3 times 1/2 raised to the h. Which of the following statements about the function h is correct? Alright, now look at the answer choice right here. We need to grab this one first, right? B less than 1 but greater than 0, this is exponential decay, right? Now, answer choice A. The function h is increasing. No, it's decreasing, right? It's going down. The function h is increasing. That's wrong. The function h is decreasing and the rate of change of h is increasing. Yes, because the function concave up, the rate of change is increasing, right? And the function is decreasing because the rate of change is negative, right? Look at this one. You draw a tangent line. You see that the Christmas tree rate of change is negative because the tangent line is going down like this, right? So the function is decreasing. 14. Selected values of the function f are shown in the table. Which of the following claim and explanation statements best fits this data, right? Now you need to find change in s and change in y first, right? So look at this one. Every single time you're going to add 3, right? And look at the right hand side. Every single time you're going to multiply by 2, right? Observe that the outputs over consecutive equivalent input value intervals are proportional, right? The common ratio is 2, right? So this is actually exponential function, right? So A is wrong because it's a logarithmic function. B is wrong, right? Logarithmic function. Only C and D could be correct, right? So we look at this one. The outputs are proportional, right? The input not proportional, right? So the answer must be C. So you need to be careful with this one, okay? Now question number 15. We need to find the change in S and change in Y, right? Now change in S, every single time you're going to multiply by 1/3, right? Now change in Y, every single time you're going to add 2, right? Now observe that the inputs over consecutive equivalent output value intervals are proportional, right? Because the common ratio right here is 1/3, right? So this is not an exponential function, right? So you need to eliminate C and D, right? Now look at this one, answer choice 8. It says the output are proportional. No, the input are proportional, right? So the answer must be B. Now let's move on to the next one. Use the graph and table of values below for problems 16 to 23. Alright, the graph of the piecewise linear function f is shown above, which is this one right here, and consists of 3 linear segments. Values of the function g and h are shown in the table above as selected values of s. Let f inverse and h inverse represent the inverse functions of f and h. Find the value of h inverse of 2 or indicate that it is not defined. Alright, so we need to find the inverse function of g and h, right? So in order to find the inverse function of g and h, we just swap x and y value, right? So g inverse is gonna be -5. For h inverse of s, we just copy this one down, right? Because the function g and the function h right here have the same s value, right? Now h inverse of 2, so you need to find the value of inverse function of h when s equals 2, right? S equals 2 right here. So the value should be 2 right here, right? So this guy equals 2. Now question 17, find the value of f inverse of 2. So remember that the input becomes the output, right? So this is the input, it becomes the output right here 2, right? So it's gonna be 0, right? Now number 18, the function k is defined by g of f of s, right? Find the value of k 0. Alright, so we substitute over here. It turns out to be g of f of 0, right? Now we look at the graph right here. We need to find f of 0 first. F of 0 is going to be 2, right? So it turned out to be g of 2. Now g of 2 is going to be -5 right here, right? So the answer is -5. Now number 19. The function m of s is g of f of s, right? We need to find m of -3. So it turns out to be g of f of -3, right? Now f of -3 is going to be -1 right here, right? So it turns out to be g of -1, right? -1 is going to be right here. So g of -1 is going to be -2, right? So the answer is -2. Next one, number 20. We need to find p of 1 where p is h of g of s, right? So we have p of 1 equals h of g of 1, right? Now g of 1, g right here is going to be -3, right? So it's going to be h of -3, right? Now look at the function h. H of -3 is going to be 4 right here, right? So the answer is 4. Number 21. Q of s equals f of s. So Q of -4 equals f of -4, right? Now f of -4 is going to be -2, right? So it's going to be f of -2. Now f of -2 is going to be right here. So it could be 1, right? Number 22. Find the value of R of 1. H of 1, right? Now the function h and 1 is going to be right here. The answer is 0, right? So it could be g of 0. Now look at the function g right here, 0. We don't see any value of s equals 0 right here, right? So this guy must be undefined. Number 23. The function Ls equals f inverse of h of s. We need to find L2, right? So L2 equals f inverse of h of 2, right? Now we need to find h of 2. It's gonna be -2, right? F inverse of -2, right? Now we need to look at the graph of the function f, right? -2 right here is the input of the inverse, right? It becomes the output, right? In the function f. So the output -2 is gonna be right here. Right? So the answer must be -4, right? Because f of -4 equals negative 2, right? Now, question number 24. What is the value of the expression log base 2 of 8 minus log 10? Alright, so this one can be written as log base 2 of 2 power of 3, right? Minus log base 10 of 10, right? Now we can bring 3 to the front, right? So it turns out to be 3 log base 2 of 2 minus log base 10 of 10, right? We know that log base a of a equals 1, right? So this guy turns out to be 3 times 1 minus 1, right? So it could be 2, right? So the answer must be B. Now question 25. Now we need to determine the value of this expression, right? So log base 9 of 3 can be written as log base 3 power of 2 of 3, right? Plus this guy same thing, log base 2 power of 2 of 2, right? Now we have the formula log base a power of k of b equals 1 over k log base a of b, right? This formula different from this formula, log base a of b power of k, right? When you bring it to the front, it's going to be k log base a of b, right? So this guy turns out to be 1/2 log base 3 of 3 plus 1/2 log base 2 of 2, right? So it's going to be 1/2. This guy equals 1, right? This guy equals 1, right? So plus 1/2 only. So it could be 1. So the answer must be C. Now let's move on to question number 26. What is the value of this expression, right? So we know that log base a of 1 always equals 0, right? Because a power of 0 equals 1, right? So this one equals 0, right? Now, this guy turns out to be negative log base 6 of 1 over 6 squared, right? So it's going to be negative log base 6 of 6 power of negative 2, right? So you can bring negative 2 to the front. So it could be plus 2 times log base 6 of 6. So log base 6 of 6 equals 1, right? So the answer must be 2. So it could be D, right? Now let's move on to question number 27. We need to simplify this one, right? So it turns out to be, you can bring this to the front. So it could be 3 natural log of e plus this one can be written as log base 3 square of 1 over 3, right? So natural log of e equals 1, right? So it could be 3 plus 2 right here. We can bring to the front. It could be 1/2, right? Log base 3. Now 3 right here I can bring to the top, so it could be 3 power of negative 1, right? Negative 1 bring to the front, it could be 3 minus 1/2, right? And you have log by 3 of 3 left, it could be 1, right? So only 3 minus 1/2, it could be 5/2, right? So the answer must be B. Now question 28. We need to simplify this one. So log 100, which means log base 10 of 10 squared, right? Remember, if you only see log a, which means log base 10 of a. So keep that in mind. Plus log base 4, right? Now 1 over 64, I can write this one as 1 over 4 power of 3, right? Now 1 over 4 power of 3, I can rewrite this one as 4 power of negative 3, right? Like this. So I bring 2 to the front, it's going to be 2, and then log base 10 of 10 equals 1, right? Plus negative 3 bring to the front, it's going to be negative 3, and log base 4 equals 1, right? So the answer must be -1, right? So A should be the answer. Now let's move on to question number 29. The decreasing function S gives the number of students inside a classroom after school ends. The table gives value of S of t for selected values of t in minutes since the school bell ended the day. If a model is constructed to represent this data, which of the following best applies to this situation? Alright, so we need to find the change in S and change in Y. We know that every single time the value of t is increasing by 1, right? And every single time the value of S of t is decreasing by 1/2, right? Alright, so the common ratio is 1/2, right? Which is less than 1, greater than 0, and this is a decay function, right? So the answer must be D. Now question 30. A fitness trainer created a new fitness program designed to help her clients increase their bench press. The trainer made estimates about the maximum amount one of her clients could bench press over time using her program. A linear regression was used to develop a model for the maximum bench press over time. The figure shows a graph of the results of the linear regression. Which of the following statements about the linear regression is true? Alright, now we look at the dot right here, and we see that there is no clear pattern at all, right? So the linear model is appropriate in this situation. So the answer must be C, right? Now let's move on to question number 31. After Mr. Passwater launches his new social media app called Passwater Vision, the number of users registered on the app begins to increase rapidly. The number of users in millions using the Passwater Vision app is modeled by the function p. The number of users is expected to increase by 21% each month. At time t equals 0 years, there are 14 million users on Passwater Vision. If t is measured in years, now you need to know the difference between this guy and this guy, right? Which of the following is an expression for p of t? Note there are 12 months in a year, right? So we know that at t equals 0, there are 14 million users, right? So this is the y-intercept or initial value, right? So we see that 14 right here, 14, 14, so which is or could be right, right? Now next one, because the number of users is expected to increase by 21% each month, right? So we know that by the exponential growth function, it's going to be f of s equals a times 1 plus r raised to the t, where r is the growth rate, right? So the growth rate is 21%, right? So this guy turns out to be 14 times 1 plus this one right here is going to be 0.21, right? So it can be 1 plus 0.21 is going to be 1.21, right? Raised to the t, right? Now because this one is just measured in month, right? We need the answer to be years, right? So there are 12 months per year, right? So we need to take this one multiplied by 12. So it can be 14 times 1.21 raised to the 12t, right? So the answer must be D, right? Now let's move on to question number 32. Polonium 209 has a half-life of 102 years. In a particular sample, the amount of polonium 209 remaining after y years can be modeled by the function p given by p of y equals a0 times 0.5 raised to the y over 102, where a0 is the amount of polonium 209 in the symbol at time y equals 0, which is the initial value, right? Which of the following functions L models the amount of polonium 209 remaining after t days, where a0 is the amount of polonium 209 in the symbol at time t equals 0. Now, here's the hint. There are 365 days in a year, so t equals 365y, right? So from this one, we can solve for y. So y equals t over 365, right? I can write this one as 1 over 365 times t, right? So I substitute 1 over 365 times t for y in this equation right here. So I'm going to end up with L of t equals a sub 0 times 0.5 raised to the 1 over 365 times t times 102, right? Now, I can print 1 over 365 inside, so it will be a sub 0 times 0.5 raised to the 1 over 365 right here, right? All together raised to the 102t, right? So the answer must be D. Now let's move on to question 33. The table above represents values for a function k at selected values of s. An exponential regression y equals a times b to the s is used to model this data. What is the value of k of 3 predicted by the exponential function model? Alright, so this question is calculator active, right? So we're going to bring up the calculator. Now, I'm going to use two different calculators. I'm going to use TI and SPI calculator first, right? So, what I need to do is to go to main screen, right? Calculator. Now, I need to hit spreadsheet right here. I need to name the first and the second column with S and Y values, right? Then, I need to input the values for this table, right? So, I just copy this one over here. Then, I'm going to move my cursor to the right of this column, right? So I'm going to hit menu, number 4 statistic, number 1 start calculation, and then I need to hit A right here, exponential regression. Alright, so for the first one, I just rename this one as, next one should be Y, right? I save my equation as F3, right? So I need to use this one later. I need to hit OK. The answer should be 5.13, which is the initial value, and the common ratio should be 0.685 something, right? Now, I need to determine the values of k of 3 right here, right? So I need to go to the home screen, right? So I need to hit Control I. Add calculator here. Alright, so I need to hit F3 because previously we saved our equation as F3, right? So F3 right here. And open parenthesis, put 3. Close parenthesis, hit enter. The answer is 1.65384. So A must be the answer, right? Now we can use TI-84 plus CE calculator to do this problem, right? So this is my calculator. Now I need to hit start, edit. Alright, the first column right here, I need to go up, hit clear, go down. The second one, go up, hit clear, go down, right? Now I need to input the values for the table, right? So now you hit start, go to count right here, and find the exponential regression. It's going to be number 0 right here. Hit enter, and then S list, which means L1, Y list, which means L2. You need to store regression equation, right? So I'm going to store this one as Y1, right? So you need to hit vars, Y-vars, function Y1, hit calculate. So the answer is right here, right? Now we need to solve for k of 3, right? So you need to hit vars, go to Y-vars right here, function Y1, right? Hit parentheses, put 3, close parentheses, hit enter. The answer is right here, 1.6538, right? Now we can also use decimals to do this problem, right? So we're gonna bring up decimals. It's gonna be right here. We hit the plus sign right here, and then hit table. Alright, we need to input values for the table, right? Now we need to hit this one right here, add regression. Alright, we need to choose exponential right here. Now we need to put the check mark on logmost right here to get the exact value right here, right? If you don't put the check mark on log mode, you will get the wrong answer. So keep that in mind, right? So the answer is 5.13047 times 0.68566 right to the S, right? Now, to find the value of f of 3, we need to copy this equation over here. Alright, so after you copy the equation over here, now you need to calculate f of 3, right? So you just put f of 3 and put equal sign and hit enter. The answer is 1.6593, right? Now let's move on to the last question, 34. A wind turbine uses the power of wind to generate electricity. The blades of the turbine make a noise that can be heard at a distance from the turbine. At a distance of d equals 0 meters from the turbine, the noise level is 105 decibels. At a distance d equals 100 meters from the turbine, the noise level is 49 decibels. The noise level can be modeled by the function s of d equals a times b raised to d, where s of d is the noise level in decibels at a distance d meters from the turbine. Use the given data to write two equations that can be used to find the values for the constants a and b in the expression for s of d, right? As d equals 0, we have s of 0 equals a times b power of 0, right? But s of 0 equals 105 decibels, right? So a times b power of 0 equals 105, right? So we have the first equation. It's going to be a times b raised to the 0 equals 105, right? Now the second one, s of 100 right here equals a times b power of 100. And then as d equals 0, it's going to be 49 decibels. So it could be 49, right? So we have the second equation, a times b power of 100 equals 49, right? Now, question B, find the values for a and b, right? So, from the first equation right here, we can say that b raised to the 0 equals 1, right? So, a equals 105, right? Now, we substitute 105 for a into the second equation. So we're going to end up with 105 times b power of 100 equals 49, right? Now divide both sides by 105. So b raised to the 100 equals 49 over 105. Now raised to the 1 over 100 both sides. So b equals 49 over 105 raised to the 1 over 100, right? Now question C, use the given data to find the average rate of change of the noise level in decibels per meter from d equals 0 meter to d equals 100 meters. Express the answer as a decimal approximation. So the computations that lead to your answer, right? So recall that the average rate of change formula is given by f of b minus f of a over b minus a, right? Now, in this situation, it's gonna be s of 100, right? Subtract s of 0, right? Over 100 minus 0. Now, s of 100 is gonna be 49, right? It's right here. Minus s of 0 is gonna be 105, right? Divide by 100 minus 0, right? 49 subtract 105 is gonna be negative 56 divided by 100. So it could be negative 0.56 decibel per meter. We're gonna talk about the inverse functions. So an inverse relation will undo a given relation, which means you're gonna switch x and y. Alright, so for example, if you have the table, now you need to find the inverse of this relation. So basically, you just switching the x and y values, right? So this is x equal 1, 3, 4, 6, right? And then this guy turns out to be y value. So you put 1, 3, 4, 6 right here. Now negative 1, 2, 0, 2 go over here. Alright, so let's take a look at the first table right here. This original table and this is the relation. We're gonna check the s value right here. You see that every single s value produces exactly one y value. So this relation is a function. Now look at the second table right here. You see that one s value right here produce two different y values right here. Alright, which means s repeating. So when s repeating, this is not a function. Alright, let's move on to the next example. Now, given the graph right here, we need to sketch the inverse relation of the given graph. Alright, so this is my original relation. So I have the points right here. It's going to be negative 2, negative 1. The next point is going to be right here, negative 1, 2. Next one is going to be 2, 1. And the last one is going to be 4, 3. Now, next one, I have the inverse relation. Alright, so basically, I need to swap x and y right here. So I get the new coordinate points. So it's going to be negative 1, negative 2. This guy right here, 2, negative 1. And then this guy, 1, 2. Right, this guy, 3, 4. Alright, so basically, I just grab this guy on the coordinate plane right here. So negative 1, negative 2, negative 1, and negative 2. The points right here. 2, negative 1 is going to be right here. 1, 2 is going to be right here. And 3, 4 is going to be right here. Alright, so I connect this guy. Okay. Now, the original relation is a function because it's past the vertical line test. right? So you draw a vertical line test, you see that every single time the vertical lines miss the graph at 1 point, right? But the inverse relation is not a function because it does not pass the vertical line test, right? You just draw a vertical line right here. You see that the graph missed the vertical lines at 3 points right here, right? So this is not a function. The graph of inverses are reflections over the line y equal x. So basically, you just draw the line y equal x right here. You see that? Original function and the inverse reflect over the y equals x. Now, if I call the original function, it's going to be f of s, and then the inverse function should be f inverse of s, like this, right? Now, let's move on to the next example. We need to find the inverse functions of this guy right here, and then we need to find the domain and range of the inverse function. All right, before we're going to do that, let's review the concept. So if two functions are inverse of each other, the domain of the original function is the range of the new function. The range of the original function is the domain of the new function. So now I need to find the domain of this one. This is actually the rational function. So if you grab it, it's going to be something like this. Now the first thing you need to find the vertical asymptote. So the vertical asymptote, you just let the denominator equal to 0. So vertical asymptote equals s plus 3 equal to 0. So s equals negative 3, right? So this is my vertical asymptote. So vertical asymptote is going to be something right here. So this is negative 3. Now the horizontal asymptote, because the degree on the numerator and degree on the denominator, they're both the same. So the horizontal asymptote is going to be 1, right? Coefficient of s divided by coefficient of s right here should be 1, right? So the horizontal asymptote right here, y equals 1. This is s equals negative 3. Alright, so this is 1. Alright, so if you grab it, it should be something like this. Alright, so the domain of this function is going to be negative infinity to positive infinity except negative 3, right? So you need to write the domain is going to be a real number except negative 3. Alright, now the range. Right, we're gonna go from bottom to top. So it's gonna be all real numbers except y equal 1 right here, right? So the range is gonna be all real number except 1. Now, if you do the right thing, and then the domain of this guy right here becomes the range of the inverse function. The range of this guy right here becomes the domain of the inverse function. Now, in order to find the inverse function of this function, the first step you need to do is rewrite this one. Replace f of s with y. Alright, so I have y equals s minus 2 over s plus 3. Now, next step, you're gonna swap y and s. Alright, so y right here you put s right here you put y. Alright, and you copy everything down. Minus 2 plus 3. Okay. Now, next one, you see the denominator right here. You need to multiply both sides by denominator. So I'm going to multiply both sides by y plus 3. Y plus 3. Alright. So then, this guy cancel out. So I have this guy multiplied by this guy. You just multiply this one out. So it could be sy plus 3s equals y minus 2. Alright, now you need to solve for y. So basically you print every single term related to y to the left. Alright, other terms print it to the right. So I have sy on the left, I just rewrite this one. Okay, I have y right here, I need to print it to the left. When you print it to the left, which means you need to subtract this one. When you print this one to the left, you need to change the sign of the terms. So when you move a term from this side to another side, please change the sign of the terms. So this is positive becomes negative y equals positive 3s. I'm going to print it to the right. So it turns out to be negative 3s minus 2. Copy them down. Okay. Now I need to solve for y. I need to factor y out. So it's going to be y right here. Right, when I factor, I need to take each of these terms divided by y. So sy divided by y is going to be s. Negative y divided by y is going to be negative 1. Close parenthesis equals negative 3s minus 2. Alright, so I need to divide both sides by s minus 1. So I have y equals negative 3s minus 2 over s minus 1. Alright, now I need to replace y with inverse function. It's going to be negative 3s minus 2 over s minus 1. Alright, so now I need to find the domain and range of this one. So this domain and range, this actually right here, right? The domain of this one should be the range of this one, right? So all real number except 1. The range of this one will be the domain of the original. So it's going to be all real number except negative 3. Alright, now I'm going to check to see if it's right. Now domain. So in order for a function to be defined, denominator must be different from 0. So I have s minus 1 different from 0. So s different from 1, right? So it's exactly all real number except 1, right? Now, the range, which means I need to get rid of the horizontal asymptote. When you write the inverse function, it's going to be something like this. The vertical asymptote is equal to 1, so it could be right here. And the horizontal asymptote is going to be negative 3, right? So it's going to be something right here. Alright, so the graph should be something like this. Alright, so we need to find the range, which means all real number except the horizontal asymptote, right? The range, you're gonna go from bottom to top, so the graph keeps going down, and this guy keeps going up, right? And the graph never touched the horizontal asymptote right here. So it's gonna be all real number except negative 3, right? So it could be right here. Now let's move on to the second example. Alright, so I need to find the inverse function of this one. Before I do this one, I need to find the domain and range of the original function, right? So domain, which means denominator different from 0, right? So s minus 3 different from 0, s different from 3, right? S minus 3 not equal to 0, s not equal to 3, right? So it could be all real number except 3. Now, the range. You look at this one, this is a rational function. The degree on the numerator is 0, less than the degree on the denominator, right? So, the horizontal asymptote is y equal to 0. So, it can be a real number except 0, right? Okay, so I need to find the inverse function, right? So, the first step you need to do is to replace g of s with y. So y equals 1 over s minus 3. Now I need to swap s and y. So this guy y becomes s. This guy becomes 1 over y minus 3. Now I see the denominator. I need to get rid of the denominator. So I multiply both sides by y minus 3. This guy, y minus 3. Alright, so this guy right here cancel out. Now I need to multiply this one. So it could be as y minus 3 as equals 1. Now anything related to y value, I move to the left, right? And anything not related to y value, I move to the right. So when you move a terms from this side to another side, you need to change the sign of the terms. Alright, so sy, I just rewrite this one. Negative 3s move to the right. It turns out to be 3s plus 1. Alright, now I need to solve for y. I need to divide both sides by s. So it could be y equals 3s divided by s, it could be 3 plus 1 divided by s, it could be 1 over s. Or you can rewrite this one as 3s plus 1 divided by s. That's fine. Okay. So look at this one. You see that the horizontal asymptote is 3, right? Horizontal asymptote is going to be 3. The vertical asymptote is going to be s equal to 0. This is y equals 3, right? Now the domain. This is the range right here. This is the domain right here. So range is going to be all real number except 3, right? And the domain right here is going to be all real number except 0, right? So we look at this one right here. We see that they are swapped, right? Domain becomes range. And then the range becomes domain right here. Okay? Now let's move on to the next example. We need to replace f of s with y, right? So I have y equals square root of s minus 3 plus 2, right? Now we need to swap s and y. So it could be s right here. And then this guy becomes y minus 3 plus 2, right? Now I need to solve for y. So I need to isolate y. So in order to do that, I need to get rid of 2 right here. So I subtract 2 both sides. So I'm going to rewrite this one as s minus 2 equals square root of y minus 3. So I need to flip this one. So it could be square root of y minus 3 equals s minus 2, right? Now I need to square both sides, right? So it could be, if I square the left hand side, the radical side is gone. So I have y minus 3. And then I need to square the right hand side. It could be s minus 2 all together square. Alright. So then I need to solve for y. It's going to be y equals s minus 2 all together square plus 3. Alright. Now if we wrap this one, it's going to be something like this. This graph comes from the parent function of the quadratic function. Shift to the right 2 units and shift up 3 units. Alright, so this is 1, 2, and this is 1, 2, 3. So it's going to be somewhere right here. So the graph should look like this. So this is the inverse function. It's going to be f inverse of s right here. Right, so I replace y with f inverse of s equals s minus 2 all together square plus 3. Right, this is my answer. So the domain is going to be all real numbers, right? Because this guy keep going further to the left, this guy keep going further to the right. So the domain is to be all real numbers. Now the range, we're gonna go from bottom to the top. So this is the minimum value. Minimum right at 3 right here. So it could be 3 all the way up. So it could be y greater than or equal to 3. Or you can write at the interval notation. It could be bracket 3 comma infinity. And this is the range. Now let's move on to the next example. Right, we need to find the inverse of each functions. Now let's move on to the next example. We need to find the inverse of each function and list the domain and range of the inverse function. So the first one is going to be f of s equals s minus 3 altogether q plus 4, right? Alright, so the first thing you need to do is to replace f of s with y. So it will be y equals s minus 3 q plus 4, right? And then you just swap s and y, right? So this is s equals y minus 3q plus 4, right? And then you need to get rid of 4 to isolate y, right? So it can be s minus 4 equals y minus 3q. Now take q root both sides. So it can be q root of s minus 4 equals y minus 3, right? Now I need to get rid of negative 3. So it could be q root of s minus 4 plus 3 equals y. Alright, so I just flip this one. So it could be y equals q root of s minus 4 plus 3, right? Now I need to replace y with f inverse, so it could be like this, equals q root of s minus 4 plus 3, right? We need to find the domain of this one. So now you see that the expression under the radical sign is going to be s minus 4, right? But this is a cube root, so you can take cube root of any number, right? 0, positive or negative, it doesn't matter. You still get the answer. So the domain should be all real numbers, right? Now the range. So this guy right here always defined. So the range should be all real numbers. And if you use a calculator, you grab this one, you see that it takes all real numbers. Now let's move on to the next one. If I have f of s minus 4 equals negative 4 times s plus 2, right? So the first thing I need to do is I replace f of s with y. So I have y minus 4 equals negative 4 times s plus 2, right? Now I need to swap s and y. So this y becomes s minus 4 equals negative 4 times y plus 2, right? So I need to isolate y. So how do I do this one? Right, I need to distribute this one first. So I have s minus 4 equals negative 4 times y is going to be negative 4y. Negative 4 times 2 is going to be negative 8, right? Now next one, I need to isolate y. So in order to do that, I need to divide both sides by negative 4. So I have s minus 4 divided by negative 4 equals y plus 2. Alright, so I need to get rid of 2. I need to subtract 2 both sides. So it could be s minus 4 over negative 4 subtract 2 equals y. Now I need to simplify this one, right? So how do I do this one? So it's going to be I rewrite y equals s minus 4 over negative 4 minus 2. Alright, so it can be y equals, you have the common denominator negative 4. So I multiply this one by negative 4. So it can be s minus 4. Negative 4 times negative 2 is going to be 8. So I plus 8. And I write everything under negative 4 like this. So y equals s plus 4 over negative 4. Now I need to write this one in the slope-intercept form. So it can be y equals, check each of these terms divided by negative 4. So it can be negative 1 over 4 s. 4 divided by negative 4 is going to be negative 1, like that. And I replace y with f inverse. is going to be negative 1 over 4s minus 1. And this is the linear function. Domain and range should be all real numbers. Okay, so domain, range, right here, all real numbers. Alright, now let's move on to the next one. Now, if the function is increasing or decreasing only, then it is invertible. If the graph turns, which means it has a maximum or minimum, then it is no longer invertible because there will be the output values that are the same for different input values. Alright, in other words, if the original graph passed the horizontal line test and then it has an inverse. So for example, if you have the graph like this, okay, then this function has an inverse because you draw a horizontal line test. You see that the horizontal line intersects the graph as 1 point only. And then its inverse will pass the vertical line test. The second example is going to be like this. Alright, this has an inverse or it is invertible. Now let's move on to the next example. If the function has an inverse, then the original function and the inverse must be reflected over the line y equal x. Alright, so basically you need to sketch the line y equal x. It's going to be like this. So this is y equals x. And this guy y equal s right here. Okay, and you see that the function on the left, this is decreasing function. Alright, so this is decreasing function right here. And the one on the right, this is increasing function. So it's going to be right here. So both of them have an inverse, right? Now, you just reflect this guy right here, right, over the line y equal s, right? So the coordinate of this point is going to be negative 3 and 1, right? So it turns out to be this guy negative 3, 1. So it turns out to be 1, negative 3. So it's going to be right here. And this guy right here is going to be 2, comma, negative 3. So it turns out to be negative 3, 2. So it's right here. Now you pick the point right here. It's going to be negative 1, 0. So it turns out to be 0, negative 1. So it could be right here. Now you pick the points right here. It's going to be 1, negative 1. So it turns out to be negative 1 and 1. So it's going to be right here. And then you just connect them. Alright, so you just connect them, and if you sketch the graph, it should be something like this. Now you do the same process for this one. Alright, so the point right here, 2, 3 becomes 3, 2, right? So 3, 2 is going to be right here. This guy right here, 1, 0 becomes 0, 1, so it could be right here. This guy, negative 2, negative 1 becomes negative 1 and negative 2, so it could be right here. And the last point, this guy, negative 3, negative 4 becomes negative 4 and negative 3. So it could be right here. Alright, so you just get this one. And again, the domain and range of the original function and the inverse will be swapped. Alright, which means the domain of original function right here is going to be from negative 3 to 2 right here, right? Right, the endpoint right here. Negative 3. So domain is going to be close bracket negative 3 2. And the range is going to be negative 3 to 1 right here. Negative 3 to 1, right? So this is from original function. Now, the inverse, you just swap this one. So the domain, you're going to take negative 3, negative 3, 1. And the range, you're going to take negative 3, negative 3, 2. And then you look at the graph right here, you see that this is exactly right here. Negative 3, 2 and negative 3, 2, 1 right here. Right? You do exactly the same thing for this one. So this guy, the domain, negative 3, 2, 2. This guy becomes the range of the inverse. So the range of inverse is going to be negative 3, 2, 2 right here. Right? The range of this one is going to be negative 4 to 3. This guy becomes the domain of the inverse function negative 4 right here. 2, 3 right here. Right? So for example, if I have the function f of s equals s minus 2 square plus 5. And we have the restrict domain is going to be s less than or equal to 2. Alright, this is actually horizontal shift 2 units to the right and 5 units up from the parent function y equal s squared, right? So 2 units to the right is going to be right here and 5 units up is going to be something like this. Alright, so if you grab it, it's going to be something like this. And then the domain s less than or equal to 0, so which means you only take this guy, right? And then if you find the inverse function, you need to get the line y equal s, right? So you know that this guy and this guy reflect over the y equal s. So if you grab the inverse function, so it's going to be something like this. Alright. Now go ahead find this one. I'm going to replace f of s with y. So it could be y equals s minus 2 square plus 5, right? So I need to swap s and y. So it could be s equals y minus 2 altogether square plus 5. I need to get rid of 5, so I subtract 5 both sides. So it could be s minus 5 equals y minus 2 altogether square. Alright, so I rewrite this one. It's going to be y minus 2 altogether square equals s minus 5. Take square root both sides, so it could be minus 2 equals plus and minus square root of s minus 5, right? Now we look at this one, we have two values right here. Now we need to know which one we're gonna pick, right? So we look at the domain right here. Domain tells us that if this function has an inverse, and then the domain right here becomes the range of the inverse function. So the range of the inverse function is going to be the one on the right hand side right here. Alright. So basically, s less than or equal to 2 is the same thing as y less than or equal to 2, right? So I have y less than or equal to 2. I subtract 2 both sides, so I have y minus 2 less than or equal to 0. Alright, so the left hand side right here less than or equal to 0. The right hand side right here must be less than or equal to 0. That's why I picked the negative side. So from here I have y minus 2 equals negative square root of s minus 5. Right? So I'm going to add 2 both sides. So it will be y equals square root of s minus 5 plus 2. This is my answer. So I just replace y with f inverse, right? It's going to be negative square root of s minus 5 plus 2. And then this is my final answer. Okay, now I need to find the domain and range of this one. So keep in mind, the domain is going to be the one under the radical sign right here, s minus 5 right here, must be greater than or equal to 0. So s greater than or equal to 5. So this is my domain. Now the range is going to be right here. You just take this one, but you replace s with y. So y less than or equal to 2. This is my range. Now I'm going to challenge you with this problem. You need to find the inverse of the following function and then find the domain and range of the inverse, right? So f of s equals 4s squared plus 4s plus 5, where s greater than or equal to negative 1/2. Right? Now let's move on to the next example. Alright, so for example, given a function f of s with the table right here. Now let g be the inverse function of f such that g of s equals f inverse of s, right? So basically, the first thing you need to do is to get the new table. I need to switch s and y value, right? Because f of s and g of s are inverse of each other. So the domain of this one becomes the range of the other one, right? So s right here, I take every single value right here. So it could be 6, 3, 1, -1, -3, and -7. The g of s is going to be -3, -2, 0, 1, 4, and 6, right? Okay, now question number 1, we need to find f of f0, right? So we start from inside to outside, from right to left when we talk about the composite function, right? f of 0 is going to be equal to 1, right? So then this guy becomes f of 1, right? It's going to be -1. So this final answer, -1. Now, g of -3 is going to be 4 right here, right? Now, g of 6 is going to be -3. Now, we need to start from g of -1 first, right? G of -1 is going to be 1. And then this guy becomes g of 1. It's going to be 0. So the final answer is 0. Now, this one we need to start from f of -2 first. So f of -2 is going to be 3. Alright, so we rewrite this one as f inverse of 3, right? F inverse of 3 is the same thing as g of 3, right? Because f inverse which means the g function, right? So g of 3 is going to be -2, right? Now this one, f inverse of -3, which means g of -3, right? G of -3 is going to be 4. Now let's take a look at this one right here. The function k is given. The domain is going to be -4 to 11. And then k inverse represents the inverse of k. Now they ask you what is the minimum value of k as the minimum value, which means the y value, right? So we look at this one right here. The minimum right here is going to be -3. So it's going to be -3 here. The minimum value of k inverse, which means the minimum of range of k inverse, right? Means the domain of the function k. So the range of k inverse is gonna be negative 4 less than equal to y less than equal to 11. It's gonna be right here, right? So the minimum value should be negative 4 right here. Now we need to find the k inverse of 6, right? K inverse of 6. So we look at this one right here. K inverse of 6, which means the y value of the original function. So the y value sits right here, right? And we find the coordinate point. It's gonna be 11, right? So this guy equals 11. Now k inverse of 4, which means 4 is the y value of original function. So 4 right here. Okay, we project down right here, and the s value should be 6. So the answer is 6. Now we need to prove that if two functions f of s and g of s are inverse, if and only if f of g of s equal s and g of f of s equal s, right? So to show that two functions are inverse, we must show that the f inverse of f of s and f of f inverse of s right here both equals s. Alright, so let's take a look at the example. For example, I have the function f of s equals 2s minus 3, and the function g of s is gonna be 1/2 s plus 3/2, right? So I need to prove that the function f of s and g of s are inverse. So I'm gonna start with f of g of s, right? So I rewrite this one f of, right, g of s is gonna be right here, right? So instead of g of s, I put 1/2 s plus 3/2, right? Now I'm gonna substitute this guy right here for s into this function. So it turns out to be 2 parentheses times 1/2 s plus 3/2 close parentheses and minus 3, right? Instead of s, I put this one. Okay, so I distribute this one 2 times 1/2 s, which means s, 2 times 3/2, which means plus 3, and then subtract 3 right here. So the answer is s, right? So I'm good right here. Now I need to check the other side. So I have g of f of s is going to be, I rewrite function g. So f of s is going to be 2s minus 3, right? So now I need to replace s right here with 2s minus 3. So it's going to be 1/2 parentheses 2s minus 3. And then I'm going to add 3/2 right here. You see that? Alright, so I distribute 1/2. So 1/2 times 2 is going to be s right here. 1/2 times negative 3 is going to be negative 3/2 plus 3/2. So it's going to be s, right? Now you need to conclude since f of g of s equals g of f of s equals s, then f of s and g of s are inverse. Now let's move on to the next one. For example, I have the function h of s equals s squared plus 10, and the function k of s is gonna be square root of s minus 10. I need to prove that this guy and this guy are inverse of each other. Okay, so this guy must have the domain as greater than or equal to 10, right? So I start from h of k of s, right? So I need to rewrite h function, right? So instead of k of s, I put square root of s minus 10, right? And then h of s equal s squared plus 10. Now h of square root of s minus 10, I replace s with square root of s minus 10. So it could be parenthesis square root of s minus 10 square plus 10. Alright, so when I square this one, I don't need to put this one inside the absolute value because I have the domain right here. Okay, so it could be I remove the radical side, so s minus 10 plus 10. So it could be s. Now k of h of s equals the function k. Now h of s is going to be s squared plus 10 right here. Okay, so the function k is going to be right here. So I just rewrite the radical side right here. Alright, now instead of s, I put s squared plus 10, right? And then I subtract 10 right here. So it's going to be square root of s squared, right? So because s greater than or equal to 10, so which means positive, so I just remove the radical side, it turns out to be s, right? So since this one equal s, this one equal s, so they both inverse. Now let's move on to the next one. So for example, I have the function n of s equals 6 over s minus 4, and the function p of s equals 6 over s plus 4, right? Now I need to restrict the domain. The domain of this one should be s different from 4, right? And domain of this one s different from 0, right? Because if s equal to 0, this one undefined, right? Alright, so now I need to evaluate n of p of s first, right? So I rewrite the function n of s, right? It's gonna be n, and then p of s, I rewrite this one. So it could be 6 over s plus 4. Alright, so the function n of s right here, so it's gonna be what? 6 over s right here, which means 6 over s plus 4, right? So I replace this one with 6 over s plus 4, and then I need to subtract 4 right here. Alright, so 4 and negative 4 cancel out. Alright, so it's gonna be 6 over s. Alright, so I 6 divided by 6 over s, which means I need to flip this one. So it could be 6 times s over 6. 6 and 6 cancel out, so the answer is s. Now, I'm going to start with p of n of s. So it's going to be, I rewrite the function p, right? Now, n of s is going to be right here. So 6 over s minus 4. Alright, now I need to substitute this one into the function p right here. So the function p is going to be 6, right, over s, but s equal this one right here. So I just write 6 over s minus 4. Alright, and then plus 4 right here. This guy right here is the main fraction, okay? So this one right here, I just flip this, so it turns out to be 6 times s minus 4 over 6 plus 4. Alright, so 6 and 6 right here cancel out. So I have s minus 4 plus 4, and it's going to be s. So this guy and this guy, they are inverse. Let's move on to the last example. For example, I have the function f of s equals cube root of 3 minus s, and the function g of s equals s q minus 3. Now I need to prove this guy and this guy are inverse. So I start from f of g of s. I rewrite the function f, and then the function g of s I replace with s q minus 3, right? It's right here. Alright, so now the function f is going to be q root of 3 minus, right, minus s, but s equal this guy right here. So I should replace this one. Don't forget parentheses, q minus 3. Now I rewrite q root. If you don't see anything, which means negative 1. So negative 1 times sq is going to be negative sq. Negative 1 times negative 3 is going to be plus 3. This guy equals q root of 6 minus sq, right? So this one not equal to s, right? We need s. Now I'm going to check the other one. I have g of f of s. Alright, so I have g of f of s, which means q root of 3 minus s. Right? So the function g right here is going to be sq. But s equal this one, so it's going to be cube root of 3 minus s right here. All together q right here, right? Minus 3. So it turns out to be, so this one q turns out to be 3 minus s, and then minus 3 right here. So 3 minus 3 is going to be 0, so it's going to be negative s. Alright, so the first one right here equal this. The second one equal negative s. They are different, so this is, they are not inverse. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.
We're going to learn how to identify the inverse of exponential functions. Actually, the inverse of exponential functions are logarithmic functions. Alright, so first we need to know how to identify the exponential functions and logarithmic functions given the tables. Alright, so in order to identify the exponential functions, we're going to look at the input and output. If the input values are changing additively, while the output values average changing multiplicatively, and then that is the exponential functions. Conversely, if the input values s are changing multiplicatively, the output values average are changing additively, which means equally spaced, and then that is logarithmic functions. Now let's take a look at the few examples. Now let's take a look at the first one. You see that the s value increasing by 1 each times. The y values multiply by 1/2 each times. So based on the definition of exponential function right here, this is actually the exponential function. Alright, let's take a look at the second one right here. We see that the s values multiply by 2 each times to get the next value, right? The y values increasing by 5 each times, which means you're going to add 5 each time to get the next value. So this is the logarithmic function. Now, let's take a look at the third one right here. We see that the s values multiply by 10 each times to get the next value. The y values multiply by 3 times to get the next values. So this is neither. Now the last one. The x values multiplied by 3 times to get the next value, right? The y values add in -5 times to get the next value, right? So this is the logarithmic function. Now let's move on to the next example. Given two functions f of s equals 5 to the s and the function g of s equals log base 5 of s, we need to prove that two functions right here are inverse of each other. So based on the properties right here, we need to prove this one. Okay, so keep in mind the base of the exponential function right here must be the same as the base of the logarithmic function right here. So they are inverse of each other. Keep that in mind when you do the multiple choice questions. Alright, so look at this one. So I'm going to start from here first. So I'm going to start from f of g of s. Alright, so this one the same thing as f of g of s equals log base 5 of s. So I just put this guy inside parentheses. Log base 5 of s. Now, this one is the same thing as, now I look at the function f of s, it's going to be right here. So I just rewrite 5 right here, right? Now you see that this is s, this is s. Now this is log base 5 of s, and then this guy must be log base 5 of s. Alright? Now we learned before, we know that a to the log base a of s equals s. Keep that in mind. This guy right here and this guy right here must be the same to apply this formula. Alright, so this guy equals s, right? Because 5 and 5 right here should be the same. So I just prove the first guy right here. This guy equals this guy. Now I need to prove the second one. So I start from g of f of s right here equals g of, I'm gonna replace f of s with 5 to the s right here. So I put 5 to the s. Alright, so the function g is gonna be right here. So I just rewrite log base 5 right here. Now you look at this one, this is s, this is s. Now this is 5 to the s. This guy must be 5 to the s. Alright, again, you learned before, if you have log base a of a to the s, alright, so you just print s to the front. So it's going to be s log base a of a. But log base a of a right here equal to 1. So the answer is s times 1, which means s. Alright, so based on this formula right here, 5 and 5 right here should be the same, right? So the answer must be s. Now, since this guy equal s, this guy equal s, so I can conclude that f of g of s equals g of f of s equals s. So the function f of s and g of s are inverse of each other. Now let's move on to the next example. So suppose I have the function y equals 5 to the s, and I'm going to ask you to sketch the inverse of this function. Alright, so based on the property of the inverse of the function f and f inverse, the line y equals s is an axis of symmetry of inverse functions. Alright, and if the point A and B belong to the graph y equals 5 to the s, and then the point B A will belong to the inverse function of this function. Alright, so the first thing I need to do is I need to sketch the axis of symmetry. So the axis of symmetry is y equals s passing origin and split the first quadrant and the third quadrant in half. So it's gonna be something like this. Alright, next one, I need to find the point on the original function. So you see that the y-intercept of this function is going to be 0, 1. And then the point on the inverse function should be 1, 0, right? So it's going to be right here. Alright. Next one, I need to find another point. So the points right here, I get this one right here. It's going to be 1, 5. And then it turns out to be 5, 1. So it's going to be right here. Now I just sketch the rough draft of this inverse function. Alright, so what do you learn from the original and the inverse functions? Now the first thing I learned, the y-intercept of this function, it's gonna be 0, 1. This one becomes the s-intercept of these logarithmic functions, which means s-intercept is gonna be 1, 0. Now the second things I learned is the asymptotes of this function, which means the x-axis right here. Do you see that? Right? The equation of the x-axis is y equal to 0. So you need to know these terminologies right here, just in case you see this one on the exam. You should be able to identify the correct answers. Alright, the asymptotes of this guy is y-axis, which means s equal to 0. Now the third one I learned is the limit of this function. Alright, the limit of the function, I call this one is f of s, and I call this one is g of s. So the limit of the function f of s when s approaches positive infinity equals, you see that s approaches positive infinity, right? This one is positive infinity, this is positive infinity, this is negative infinity, and this one is negative infinity. Alright, so when s approaches positive infinity, which means s goes to the right, the function keeps going up forever. Do you see that? Alright, so it's gonna be positive infinity. Now limit of the function f of s when s approaches negative infinity, right? Look, when s approaches negative infinity, which means s going further to the left, the function approaches 0 because it's getting closer to the x-axis. So this one should be equal to 0. Now for this function, the limit of the function g of s when s approaches positive infinity is going to be positive infinity, because when s approaches positive infinity, the function is going up, right? So it's going to positive infinity. Now limit of the function g of s when s approaches 0, right? Not negative infinity, it's 0 right here, because the function can't pass the y-axis, right? So the function g of s approaches negative infinity because it's going down right here. You see that? Alright. Now, number 4. The function f of s is concave up or concave down. Alright. So when the function is concave up, it should be something like this. Alright, or half of this one, which means you're gonna cut this one in half. So it turns out to be something like this or something like this. The function's concave down is going to be something like this. When you cut this one in half, it should be something like this or like this. Alright, so we look at this one, we see that the function is concave up, right? So this is concave up. Now we look at this one right here, it should be something like this right here, right? So the function is concave down. Alright, next one. The function is increasing or decreasing, right? So we look at the rate of change. In order to do that, we just sketch the tangent line. Okay, so keep that in mind. Now, here's the trick. Keep in mind, we have the Christmas tree trick. Alright, if the lines go this way, right, go up this way, the slope is positive. If the line goes this way, the slope is negative. Alright, if the line is horizontal, the slope is 0. If the line is vertical, the slope is undefined. Look at this line right here. The lines go this way, the slope is positive. And if the line is steeper, the slope is bigger. Conversely, if the line goes this way, and then if the line is steeper, the slope is smaller. Now, based on this instruction, we're going to explore the function f of s and g of s to see if the function is increasing or decreasing at an increasing rate or decreasing rate. Alright, so we look at the function f of s right here. We just draw a tangent line. So we see that the tangent line of the functions go this way, which means the slope is positive, so the function is increasing. Alright, now we're going to see if the function increasing at an increasing rate or decreasing rate. So we keep drawing tangent line. And we see that the tangent line is getting steeper and steeper, which means the slope is bigger and bigger. So the function is increasing at an increasing rate. Now we look at the right hand side right here, the function g of s. Alright, so we still draw the tangent line, and we see that the tangent line still go this way, so the function is increasing. Now the function is increasing at an increasing rate or decreasing rate. So we keep drawing tangent line. We see that if we draw the tangent line right here, we see that this guy right here is steeper than this guy. And then we see that the line is getting less steep, right? Then the function is increasing at a decreasing rate. Now let's move on to the next question. Now I still use this graph, and if the questions ask you to approximate the value of log base 5 of 2 using this graph right here. Alright, so we look at this one right here, the formula is going to be log base 5 of s right here. And then we need to approximate the value of log base 5 of 2. Alright, so which means s right here equals 2. Alright, so we look at this one, and then the function g of s, which means the log base 5 of s right here. So we're going to use this guy right here, right? We use the function g of s right here. Alright, so s equal to right here, and then I project down to the x-axis and the y-axis right here. And I see is that the function log base 5 of s when s equal to is going to be approximately 0.4. Now let's move on to the next example. Given the function k of s equals a to the s, passing 2, 3, and 6, 27. We need to find the average rate of change of the function m of s equals log base 8 of s on this interval 3, 27. Now first we observe that this guy's the base is a, this is a, and this is s, which means the function k of s and m of s are inverse of each other. So since two functions are inverse of each other, the domain of this function will become the range of the other function. So this guy right here, the function log base a of s right here, will pass the point. This is 2, 3. This turns out to be 3, 2. Alright. This guy 6, 27 turns out to be 27, 6. Right? Alright. So we have the formula of the rate of change. It's gonna be f of b minus f of a over b minus a. Alright, so we look at this one right here. This guy right here is a, f of a. This is b, and then this is f of b. In this situation, it's gonna be m, right? Right here, the function m. So we just replace f right here with m. Alright, so keep that in mind, the function m. So we have m of b minus m of a over b minus a. And we just plug it in. M of b right here equals 6 minus m of a, which means 2, over b, which means 27, a, which means 3. Alright, we just simplify this one. 6 minus 2 is going to be 4. 27 minus 3 is going to be 24. And we simplify this one, it turns out to be 1, 6. Alright, so let's move on to the next example. Given the function f of s equals 2 times log base 2 of s, and the function g of s equals 2 power of 2 of s. Now, we need to determine if the function f of s and g of s are inverse of each other. Alright, so in order to do that, we need to use the formula right here. Alright, so first I'm going to start from f of s of f of g of s, right? It's going to be the same thing as 2 times log base 2 of s. But in this situation, s should be g of s, right? So I have put parentheses right here. 2 power of 2 of s. Now we apply the formula right here. Alright, for this one. So it turns out to be 2 times 2s. It's going to be 4s. Alright, the bottom one right here, we're going to have g of f of s. It's going to be 2 to the 2. Now we need to replace s with f of s, which means this guy's multiplied by 2 log base 2 of s, right? So we're going to simplify this one. So it turns out to be 2 to the 4 log base 2 of s. And then I apply the formula right here. Alright, I can print k back over here. Alright, so I have 2 power of log base 2 of s, and then power of 4 right here. And then I'm going to apply the formula right here, the first formula. And then the answer must be s power of 4. Now we look at this one right here. This is 4s and this is s power of 4. They are not the same and they're not equals s right here. And then the function f of s and g of s are not inverse of each other. Now let's move on to the next example. So I have the function f of s equals 10 to the 0.25s and g of s equals 4 log s, right? I need to determine that if f of s and g of s are inverse of each other. Alright, so I'm going to start with f of g of s equals 10 to the 0.25. Now s value right here, I need to replace with 4 log s, right? So it's going to be multiplied by 4 log s. Alright, now I need to simplify this one. So it turns out to be 0.25 times 4, which means 1, right? So I have 10 to the log s. Alright, so I know that if I just write log, which means log by 10, so I just rewrite this one as 10 log by 10 of s. So I look at this one, this guy, the same thing right here. I apply the first formula right here. So the answer must be s. Alright, now let's move on to the next one. G of f of s equals the function g right here. It's going to be 4 log s, but s equals f of s, right? So I just replace s right here with 10 to the 0.25 s. Alright, so this guy turns out to be 4 log right here. There is no base, which means base 10, right? So I just write log base 10 of 10 to the 0.25 s, right? Alright, so I'm gonna apply the formula right here. Alright, so the answer for this guy right here equals 4 times 0.25 s, right? And then this guy equals s, right? Because 4 times 0.25 equals 1. So both of them equals s. So then this guy and this guy right here are inverse of each other. Now let's move on to the next example. We need to find the inverse of this function. Alright, so this is the exponential functions. So by the definition right here, the inverse of this function must be the logarithmic function, right? So our goal is we need to find the inverse. Alright, so we have h of s equals 4 to the 5s. Alright, so we learned before. In order to find the inverse of the function, we need to replace h of s right here with y. Alright, so y equals 4 to the 5s right here. Alright, now next one, we need to swap s and y. So this guy turns out to be s. And then this guy turns out to be y. So 4 to the 5y right here. Okay. So next one, we look at the base right here. Alright. We see this is 4. And our goal is to find the inverse of this function. It turns out to be the log function, right? So we need to take log base for both sides because the base right here is 4. And remember that the exponential functions and the logarithmic functions, if they are inverse of each other, they must have the same base. Alright, so I'm going to take log base for both sides. So I have log base 4 right here, and this guy's log base 4. Now I just fill in this one. So it's going to s equals 4 to the 5y. Alright. So I'm going to apply the formula right here. Alright. For this guy right here. So what do I have? I have log base 4 of s. I just rewrite. This one turns out to be 5y. Alright. Now I need to solve for y. I divide both sides by 5. So I have y equals 1 over 5 log base 4 of s, right? And then this guy right here, I just replace y with h inverse of s equals 1 over 5 log base 4 of s. And this is the answer. Now let's move on to the next example. For example, if I have the function m of s equals 5 times log base 2 of s. Alright, so I need to find the inverse of this function. And given the logarithmic functions, the inverse must be exponential, right? So that is my goal. And you look at this one, the base right here, 2, right? So the exponential function must have the same base, right? So this is the base 2, alright? Now, we start from here. Alright, so we have this is ms, we just put this is y equals log base 2 of s, and this is 5 right here, right? Now we just swap s and y, so it's going to be s equals 5 log base 2 of y, right? So we look at this one, we see the number 5 in front of log, so we need to eliminate number 5 first. Alright, in order to do this one, I just bring this one back over here. I use the formula right here. Alright, so it turns out to be s equals log base 2 of y power of 5, like that, okay? The reason why, because I need to apply the first formula right here, right? I'm going to turn this one into the exponential both sides with the base 2. So I put the base 2 right here, the base 2 right here equals right here. Alright, so I put this one as exponent, right? As, and this guy as exponent. Log base 2 of y power of 5. Because the exponential function and the logarithmic functions have the same base. This is 2, this is base 2. I need to create base 2, okay? So, for the right hand side right here, I'm going to apply the first formula right here, this guy. So it turns out to be 2 to the s equals y to the 5th, right? Okay, now I need to solve for y. So I need to raise to the 1/5 both sides. So it's going to be 2 to the s all together power of 1 over 5. Alright, equals y, right? Because y power of 5 raised to the 1/5. And then 5 right here cancel out. The answer must be y. That's why we have this one. Alright, so this one I'm going to multiply the power. So it's going to be y equals 2 to the s over 5. Now I need to replace y right here with m inverse, right? So I have m inverse of s equals 2 to the s over 5. And that is the inverse function of the original function. Now let's move on to the next example. We need to find the inverse of this function right here. Alright, so this is the logarithmic functions. So our goal should be the exponential, right? And then I see the base right here, 8. And then the base of exponential must be 8. Now I need to swap s and y, right? So I have s right here equals 1 for log base 8 of y, right? And then what I'm going to do next is I need to eliminate 1 4 right here, right? So in order to apply the formula right here. Alright, so I need to multiply both sides by 4. So it's turned out to be 4s equals log base 8 of y, right? And my goal should have the base 8 in the exponential function, right? So I need to take base 8 both sides, right? Of 4 to the s, and this is of log base 8 of y, alright? Now I need to apply the formula right here. So the left hand side should be a to the 4s. The right hand side should be y. So I need to rewrite this one as y equals a to the 4s. And then I need to replace y with f inverse, right? Of s equals a to the 4s. And that is the answer for this question. Now let's move on to the next one. We need to find the inverse of these exponential functions. Alright, so this is exponential function with the base 10, right? So our goal is the logarithmic function, right? And then the base right here, 10, and then this guy must have base 10 right here, okay? So the first thing I need to do is I replace t of s with y, right? So y equals 10 to the 3 over 4s. Alright, next one, I need to swap s and y. So this guy is s, this guy 10 to the 3, 4, y. Alright, so now I see the base 10 right here, and I need to take log base 10 both sides, right? So I have log base 10, and this is log base 10. Alright, so I need to rewrite everything. So this is s, and this is 10 to the 3 over 4y. Alright, so for this guy right here, I need to apply the formula right here. Okay, so it turns out to be log base 10 of s equals 3 over 4y. Alright, so I'm going to multiply both sides by 4 over 3. So it turns out to be y equals 4 over 3 log base 10 of s. And we learned that log base 10, we just write log, right? So y equals 4 over 3 log s like this, okay? And we just replace y with t inverse of s equals 4 over 3 log s. Topics 2.3, 2.10, and 2.11. Exponential and logarithmic graphs. Before we dive into the review, let's activate Bryan knowledge. We're going to explore the end behavior and concavity of the exponential functions. So exponential function is given by the formula y equal to a times b power of s, where a is the initial value or the y-intercept, b is the common ratio. Now, a must be different from 0. B must be different from 1. Alright, so we have two different cases. If b greater than 1, this is the exponential growth. If b greater than 0, less than 1, this is the exponential decay. Now we have four different cases. The first case, a greater than 0, b greater than 1. Alright, so this is exponential growth. So the function rise from left. So it's going to be something like this. Now, the second case, a greater than 0, b greater than 0, less than 1. So this is exponential decay. So the function falls from left. Now the third case, a less than 0, b greater than 1. The function looks like this. And the last case, a less than 0, b greater than 0, less than 1. So the function looks like this. So in four cases right here, the exponential function receives the x-axis as the asymptote. Alright, so this is the x-axis. The function of the x-axis is y equal to 0. Keep that in mind. The function of the y-axis, which is x equal to 0. We're going to use decimals to demonstrate the graph of 4 different cases of the exponential functions. The first case, a greater than 0, b greater than 1. So I'm going to let a equal to 1 and b equal to 2. Alright, so I have the first exponential function y equal to 1 parenthesis 2 power of x. Alright, so it's going to be like this. Now the second case, I'm going to let a equal to 1 but b equal to 1/2. So let's see how it looks like. Y equal to 1 times 1/2 power of x. Right, it's gonna be like this. So look, it looks exactly the same thing as this guys right here. Now case number 3, a less than 0, b greater than 1. So I'm gonna let a equal to -1, b equal to 2. So the third case, y equal to -1 times 2 power of x. Alright, it's gonna be right here. So it looks like this one. And the last one, a less than 0. So I let a equal to -1. And b from 0 to 1. So I let b 1/2. Alright, so I'm gonna have the last one. So y equal to -1 times 1/2 power of x. So it could be like this. Alright. Now we're gonna explore the end behavior and concavative as well as increasing or decreasing. Alright. Now in order to explore the end behavior of the exponential function, the first thing we need to do is to put the positive infinitive on the right of the x-axis, negative infinitive on the left of the x-axis, positive right here, and this is negative right here. Alright, so limit of the function f of s. So this is the function f of s. When s approaches negative infinitive, so you see that when s approaches negative infinitive, which means s going further to the left, the function is the red line right here, getting closest to the x-axis, and as we know that the x-axis, which means y equal to 0. So the limit of the function f of s when s approaches negative infinitive is going to be equal to 0. Now b, limit of f of s when s approaches positive infinitive, so which means s going further to the right, right? And the function going up. So which is the function approaches positive infinitive right here. Alright, so it could be positive infinitive. Now next one, we need to explore to see if the function is increasing or decreasing at an increasing rate or decreasing rate. Alright, so before we do that, let's take a look at the trick. We call this is Christmas tree trick. Alright, now if you see the lines going up from left like this is increasing, which is the slope is positive. The guys going down from left like this, the slope is negative. If you see the horizontal line, the slope is 0. If you see the vertical lines, the slope is undefined. Alright, so I'm going to use this Christmas tree. Now look at this one right here. I'm going to draw a tangent line to see if the function increasing or decreasing. Alright, so I keep drawing tangent line like this. And you see that it looks like this line right here, right? Right. So the function is increasing, right? Now, the function is increasing at an increasing rate or decreasing rate. So we start from here. We know that the horizontal line right here, the slope is 0. So we start from 0 and then it's getting steeper and steeper. So, right, so if it go this way and if it's getting steeper, the slope is bigger. Alright, so which is the function is increasing at an increasing rate. Alright, now in order to understand if the function is concave up or concave down. Okay, so we look at the streak right here. So if you see a bow like this here, the function is concave up. Alright, now let's move on to the second case right here. Alright, we have the limit of the function f of s when s approaches negative infinity. So when s approaches negative infinity, the function approaches positive infinity. Look, it keeps going up forever. So it can be positive right here. So we have limit of the function f of s when s approaches negative infinity is positive infinity. Now, next one, limit of the function f of s when s approaches positive infinity. Right, so when s approaches positive infinity, which means s going further to the right, the function getting closer to the horizontal asymptote, which is 0 right here, right? So this guy must be equal to 0. Now, C, the function is increasing or decreasing at an increasing rate or decreasing rate. We just draw tangent lines, right? So we see that the tangent lines go this way, right? Which is this one right here. So the function is decreasing. Now, if we keep drawing tangent line, we see that if the tangent lines go this way, right, the steeper, the smaller slope. Alright, so this is steeper right here. And this guy getting less steep. And this guy getting less steep. Alright, so the tangent line getting less steep. And until the tangent line approaches 0, which is the horizontal line right here. Alright, so which means the function decreasing at an increasing rate, right? Because, for example, this guy equal to negative 5, right? This is negative 4, right? Negative 3, negative 2, etc. until 0, right? So you see that the slope of the tangent line is increasing, right? So this is decreasing at an increasing rate. Now we need to determine if the function is concave up or concave down, right? So this is part of this guy right here, right? So the function is concave up. So D, the function is concave up. Alright, let's move on to number 3. Alright, so we have the limit of the function f of s when s approaches negative infinity. So when s approaches negative infinity, which means s going further to the left, the function getting closer and closer to 0, right? So this guy must be equal to 0. Now, limit of the function f of s when s approaches positive infinity, right? When s approaches positive infinity, the function getting down to negative infinity, right? Negative infinity right here, because it keeps going down right here, right? So it's going to be negative infinity. Now, C, the function decreasing, right? Because we draw a tangent line, we see that the tangent lines go in this way, right? Which is this one right here. right? The tangent line is going this way, so this is decreasing. Now, decreasing at an increasing rate or decreasing rate. So we keep drawing tangent line. We see that the function starts at 0 right here. It keeps getting steeper and steeper, but steeper this way right here. So which means the slope getting more negative, right? So if it's getting more negative, which means the function decreasing at a decreasing rate. Alright, the function is concave down. If you see something like this, alright, or part of this guy, right, the function is concave down, right? So the function is concave down. Now let's move on to the last one. We need to find the end behavior of this exponential function. So limit of the function f of s when s approaches negative infinity. So when s approaches negative infinity, which means s going further to the left right here, the function getting down, right? So it's going to negative infinity right here. So it's going to be negative infinity. Now b, the limit of the function f of s when s approaches positive infinity. When s approaches positive infinity, which means s going further to the right, right? And the function getting closer to 0, right? So which is 0 right here. Now c, the function is increasing or decreasing at an increasing rate or decreasing rate. So we need to explore that one, right? So we start right here, we see that. Now we start drawing the tangent line right here, right? The tangent line right here. You see that the tangent line is getting less steep, right? And you see that the tangent line is going this way right here, right? Which means it's positive, right? It's positive, which means the function increasing. But it's getting less steep, right? Until it approaches 0, right? So the function is increasing at a decreasing rate, right? We're gonna learn about the logarithmic functions. Suppose I have the function y equals 2 to the s. Alright, so this is exponential function. Alright, we have the general form. The exponential function is going to be y equals a times b to the s, right? So in this situation, a equals 1, b equals 2, right? 2. We have two different cases of exponential function. The first case, b greater than 1. The second case, b greater than 0 and less than 1. So in this situation, b equals 2, which is greater than 1. So we're going to explore the first case, b greater than 1, right? How do we find the logarithmic function? We know that exponential function is the inverse of logarithmic function, and logarithmic function is the inverse of exponential function, right? So if both functions are inverse, they will reflect each other over the line y equals s, right? So I'm going to draw like y equals s. It's going to be something like this. Now the logarithmic function will be the reflection of the exponential function over the line y equals s. Alright, so you look at this one, the y-intercept right here, 0, 1, becomes the s-intercept right here, 1, 0, right? You're going to pick another point. This is 1, 2, and this becomes 2, 1 right here, right? This one, 2, 4, right? And this becomes 4, 2. So this 4 and 2 right here. Alright, and then you just connect these points. Now, in order to find the equation of this logarithmic function, we just take the inverse of this one. Alright, so how do we do that? Right, so we just swap s and y. It's going to be s equals 2 to the y, right? And then we look at this one right here, we see the base 2, so we're gonna take log base 2 both sides, right? So this guy's same thing as log base 2 of s log base 2 right here, right? So I just fill in the blank right here. This is s and this is 2 to the y. All right, now this one I just bring y to the front, right? So it's gonna be log base 2 of s equals y times log base 2 of 2, but log base 2 of 2 is equal 1, right? So I have y equals log base 2 of s, and y, which means f inverse of s equals log base 2 of s. So the logarithmic function has the equation log base 2 of s, and this guy y equals 2 to the s, right? Okay, so now we're gonna explore the end behavior and characteristic of these two functions, right? Now first, all right, now we need to find the x-intercept. So x-intercept is gonna be none, right? Because the exponential function right here never touch the x-axis, right? The x-intercept for the logarithmic function right here is gonna be 1, 0, right? 1, 0. Now the y-intercept for this one is gonna be 0, 1. And the y-intercept right here, none, right? Right, asymptote of this one should be the x-axis of y equal to 0. The asymptote for this logarithmic function should be y-axis, right? S equal to 0, right? The function right here is you just sketch the tangent line and you use the Christmas tree trick. So I have the Christmas tree right here. Now if the lines go in this way, the slope is positive. If the slope is positive, the function is increasing. The lines go in this way, the slope is negative, and the function is decreasing. All right. If you see the horizontal line, the slope is 0. If you see the vertical lines, the slope is undefined. Right? Now, when you draw a tangent line of this exponential function, it's going this way, which means right here, the slope is positive. Right? So because the slope is positive, the function is increasing. Now, you draw another tangent line. I draw this one right here. Alright, so look at the left hand side right here. If the line goes this way, and when the line is steeper, the slope is bigger. Now look at the right hand side. If the lines go this way, if the line is steeper, the slope is smaller. Now back to this question right here. So you see that this line and this line right here, right, from bottom to top, the line getting steeper, right? So because the line is steeper, the slope is bigger, right? Which means the rate of change is increasing. For example, the slope of this one equals 3 and the slope of this one is equal 5, right? So you see that to get 5 from 3 is going to be increasing by 2, right? So the function is increasing at an increasing rate. Alright, now go to the right hand side right here. It's going to be the logarithmic function right here. So you're going to draw a tangent line. So I draw a tangent line. And I still see that the lines go in this way right here. And then the slope is positive. So because the slope is positive, the function is increasing. Alright, in order to know if the function is increasing at an increasing rate or decreasing rate, I need to draw another tangent line. So I draw another tangent line right here. Alright, So I'm going to compare the slope of this guy and the slope of this guy. So I use this one right here, right? The line is steeper, the slope is bigger, right? The slope of this line right here is bigger than the slope of this guy right here, right? So for example, this is 5 and this is 3, right? So you see that to get 3 from 5, does that mean it's going to be decreasing, right? So the function is increasing at a decreasing rate because the slope of the tangent line getting smaller and smaller, right? Now concave. Now if you see the bow like this, if I cut this one in half and I only see half of this one, half of this one. So if you see 3 cases right here, and then the function is concave up, right? So you look at this one right here, the exponential function right here is similar to this one right here. So the function is concave up. Now if you see the bow upside down like this, or you cut this one in half and you only see half like this or half like this, right? The function is concave down, and you look at this one, it's going to be on the left hand side right here. So the function is concave down. All right, the domain of this exponential function is going to be from left to right, and you see that the function keeps going up and right, up and right. So the domain should be negative infinity to positive infinity, or you just say all real numbers, right? The domain of this one, you see that the asymptote of the logarithmic function is x equal to 0 on the y-axis, right? So the function starts from 0 all the way to the right? And the graph never crosses the y-axis. So the domain should be 0 to infinity. And you don't take 0 because x equal to 0 is the vertical asymptote, right? Now the range, which means you look at the y-axis, right? And you see that the function is always above this x-axis, right? And never touches the x-axis. So the range should be from 0 all the way to infinity, right? So you have infinity right here, negative infinity right here, positive infinity right here, and negative infinity right here. All right, so the range should be 0 to positive infinity. Now the range of this one is going to be negative infinity to positive infinity because the graph keeps going up, right, and going down, right? So the range should be negative infinity, positive infinity, right? And you know that because the exponential function and logarithmic function, they are inverse, so the domain of this function will be the range of the other function, right? You just grab it. The limit of the exponential function f of x when x approaches negative infinity, right? This is called left limit. All right. So when x approaches negative infinity right here, the function approaches 0. It never touches the x-axis, right? So this guy should be 0 when x approaches negative infinity. Now when x approaches positive infinity, right? X go to the right and the function keeps going up forever, right? So this guy, this should be right limit. Alright, so the function of f of x when x approaches positive infinity is positive infinity. Now take a look at the logarithmic function right here. So we need to find the left limit and the right limit. So left limit right here and right limit right here. Now left limit, the limit of the function f of x when x approaches 0 plus. So keep that in mind, 0 plus, which means 0 from the right. So when x approaches 0 plus, the function approaches negative infinity, right? 0 plus, so it could be somewhere right here. So you see that the function approaches negative infinity because it keeps going down. So this guy negative infinity. Now the right limit of the function f(x) when s approaches positive infinity. The function approaches positive infinity because it keeps going up, right? So this guy positive infinity. Now let's move on to the second case of exponential function. Now in this situation, I'm gonna let y equals 1/2 to the s. So in this situation, b greater than 0, less than 1. And this is a decay function, right? Now I need to get the inverse of this exponential function. So it should be logarithmic function. So I need to sketch the line y equals s, and both exponential functions and logarithmic functions reflect over the line y equals s. Alright, so this is the logarithmic function. Now, in order to find the logarithmic function, I'm gonna rewrite the exponential function y equals 1/2 to the s, right? So I just swap x and y. So it turns out to be s equals 1/2 to the y, right? I look at the base right here, it's gonna be 1/2. So I take log base 1/2 both sides, right? So I have log base 1/2, and this is log base 1/2, right? So I put s right here, I copy everything down. Alright, so this one I just print y to the front, so it's gonna be log base 1/2 of s equals y log base 1/2 of 1/2. Alright, so I know that this guy equals 1, right? So finally we have y equals log base 1/2 of s, and let's just change this one into inverse of s equals log base 1/2 of s, right? So the function right here, log base 1/2 of s, right? Alright. Now the exponential function, the x-intercept is none, right? The x-intercept for the logarithmic function is going to be 1, 0. The y-intercept for the exponential function is going to be 0, 1. And then this guy is none. The asymptote, this guy exponential function has the x-axis. So x-axis as an asymptote of y equal to 0. Alright, the logarithmic function, the asymptote is the y-axis. S equal to 0. Now, look at this one and use the Christmas tree trick, right? I'm going to draw tangent line. So I draw a tangent line like this. And let's see that the lines go in this way. So the slope is negative. The slope is negative, the function is decreasing, right? So decreasing. Now, I draw another tangent line to see if the function is decreasing at an increasing rate or decreasing rate, right? So I draw the next tangent line right here. Now I compare the slope of this guy and this guy. I see that the line less steep, right? The line less steep, the slope bigger. You look at this one, this guy and this guy right here. This guy right here is steeper than this guy. So the slope of this guy is smaller, right? For example, this guy's slope is -5, right? Because it's going this way. The line is steeper, the slope is smaller, and this guy is -3, right? So from -5 to -3, it's going to be increasing, right? So the function is decreasing at an increasing rate. Alright, now look at this guy right here. So I draw the tangent line right here, and I see that the lines go in this way, which means the slope is negative. The slope is negative, the function is decreasing, right? Now, next one, I draw the second tangent lines of this graph right here, and I compare the slope of two tangent lines right here. I see that the tangent lines right here is steeper than this one. So if the tangent line is steeper, the slope is smaller, right? So this guy right here, for example, this guy right here, -6, and this guy is -2. You see that? And then, all right, so you see that from -6 to -2, this is going to be increasing. So the function is decreasing at an increasing rate. All right, look at the exponential function right here. We see that the function is concave up because it has this guy, right? So this is concave up. And the logarithmic function is also concave up. Now the domain, right, this guy keeps going further to the left, this guy keeps going further to the right. So the domain right here should be negative infinity to positive infinity. The domain for this guy is right, is from 0, right, because the function never crossed the y-axis. So it could be from 0 to positive infinity, right? Now the range right here, look at the exponential function right here, is above the x-axis, so the range should be from 0 to infinity. And the range for the logarithmic function right here is going to be negative infinity to positive infinity, right? Oh, it keeps going down and this guy keeps going up. Now the left limit and the right limit. So left limit, look at the exponential function right here, limit of f of x when s approaches negative infinity is positive infinity because the function is going up forever, right? This guy positive, this guy negative infinity, this guy negative infinity, and this guy positive infinity. Now the limit of the function f of x when s approaches positive infinity, right? And then the function approaches 0, right? So it's 0 right here. Now the left limit and the right limit of the logarithmic function. So the left limit of the function f of x when s approaches 0 plus the function approaches positive infinity, right? 0 plus right here, the function is going up forever. Now the right limit, the limit of the function f of x when s approaches positive infinity, the function approaches negative infinity because it keeps going down forever, right? When s approaches positive infinity, right? Alright, so next we're going to learn how to sketch a logarithmic function. How do we know the function is going up, down, left, right? So we know that if I just write ln, which means the log base e, right? But if I just write log like this, which means log base 10, right? Now let's talk about log s, right? So log s, which means log base 10 of s, right? Alright, so let's explore 4 different cases of the graph of the logarithmic function. So the first one, this is the base case. I have log base 10 of s, so I just write log s right here. So the base case is going to be like this. Now let's recall the transformation of the function, right? It's going to be a times f of b of s minus h plus k, right? If you multiply the input by -1, the function reflects over the y-axis, right? So this guy right here, it turns out to be like this. right? Now, the third case, if you multiply the output by a -1, alright, so the function reflects over the x-axis, alright? So original function right here, when it's reflect over the x-axis, it could be something like this. Alright, and the last case, if you multiply the input and output by a negative number, like this, and then the function reflect over the x-axis and the y-axis. Alright, so based on the transformation rule, right, we need to do B, H, A, K, right? So we need to do the horizontal dilation first, right? So we need to reflect the original function right here over the y-axis first, right? Because you multiply the input by -1. So I reflect over the y-axis. So it's gonna be something like this. Alright, so from this one, I reflect over the x-axis because I have the negative side right here. Now we need to do B first and then we do A later, right? A, which means vertical dilation, right? So -1 right here, and then I reflect over the x-axis. So it could be something like this. Alright, so the final answer should be this guy, the red one. Alright, now the trick for you to memorize is you look at the side right here. Now you see that you don't see the negative side, which means this is positive and this is positive. Positive in front of the whole thing, which means y value. Positive in front of s, which means positive s, right? Positive s, so go to the right here, this is positive s. Go to the left, this is negative s. Go up, positive y. Go down is -1, right? So this go to the right, so s positive. Go up, this is positive y, right? Right here, right? Now this one right here, you see that positive y and negative s. So go over here, negative s, and go up, positive y, right? Now look at this one, negative y and positive s, right? So this is positive s and negative y, right? Because the graph keeps going down. Now this one, negative y and negative s, right? So go to the left, negative s, and go down, negative y. So the function go to the left and go down, right? Now let's move on to the next example. So given the function f of s equals log base 5 of s. Now describe the transformation of the function f of s to get the function g of s equals 3 log base 5 of s plus 2 minus 4, right? So we look at the transformation formula right here. Now we need to do the dilation first. So dilation right here, we have no horizontal dilation, right? Now we look at this one, this is the plus side, the formula is subtraction side, right? So when we see the plus side right here, think opposite. So first, right, the function f of s is moved to the left 2 units, right? Now next one, we talk about the vertical dilation, which means A right here. So it's going to be vertical dilation by a factor of 3. And the last one, we talk about -4 right here, which means K right here. Vertical translation down 4 units. Alright, so how do we find the vertical asymptote of this one? You just let this guy equal to 0, right? So you have s plus 2 equal to 0. You solve for s, so s equal to -2. So your vertical asymptote is s equals -2. Now to graph this one, you know that original function log base 5 of s is going to be something like this, right? And then the new function right here is going to be vertical dilation, translation left 2 units, right? So you have the vertical asymptote right here 0, right? So you move to the left 2 units. So you have new vertical asymptote is going to be right here. Alright. And then the function is moving down 4 units and vertical dilation by a factor of 3, right? So it's going to be something like this. Alright, so you need to find a new domain. So domain is going to be from -2 to infinity, right? And the range is going to be all real numbers, right? So it's going to be -infinity to positive infinity. Alright, the function is concave down. Now, the left limit of the function f of s when s approaches -2 plus, right? -2 from the right, right? So -2 plus is going to be -infinity, right? Because the graph keeps going down. Now limit of the function f of s when s approaches positive infinity. The function approaches positive infinity, right? Because it keeps going up forever. Or you can use the trick I showed you in the previous example, right? You look at this one, this is plus sign, and this guy is plus sign, right? When s approaches positive infinity, the function approaches positive infinity, right? To the right and up. Alright, so to do this one, we just rewrite this one a little bit. So it's going to be 3 log base 5. Alright, so we just rewrite this one in this form right here. So I just factor -1 out. So I have negative of s minus 3 plus 1, right? The first thing I need to do is to find the vertical asymptote. So vertical asymptote is going to be, I just let this one equal to 0 right here. So I have 3 minus s equal to 0. So I have s equals to 3. Alright, so the first thing I need to do is look at the trick right here. I need to do horizontal dilation. So we have no horizontal dilation, alright, because the coefficient is -1 right here. But we have the vertical reflection, right? So the function f of s reflects over the vertical asymptote, right? It's not y-axis anymore, right? This should be vertical asymptote. Now next one, we talk about the h right here, which means horizontal translation. So obviously the function moved to the right 3 units, right? Now next one, we talk about the vertical dilation right here. So vertical dilation by a factor of 3. And the last one, we talk about k right here. K is equals 1, right? So this is vertical shift by 1. Alright, so now we're gonna graph this one. So we have the original function is going to be like this. The vertical asymptote is going to be 3. So this is 1, 2, and 3. 3 right here. Alright, so we draw a vertical asymptote. Alright, now we just get the new one. So the new one should be something like this. Alright, now we need to find domain and range of this one. Domain is going to be -infinity to 3 right here, right? Range, it should be -infinity to positive infinity, right? Because the graph keeps going down and going up right here. Now, the function is concave down, right? And we have a vertical asymptote as equal 3. Okay, now the end behavior. So the left limit of the function g of s when s approaches negative infinitive, right? The function approaches positive infinitive. Now limit of the function g of s when s approaches 3 minus, right here. This is the right limit. So it's going to be negative infinitive because the function keeps going down, right? Now let's move on to the last example. So for example, I have the function g of s is negative log base 5 of s minus 3 minus 2, right? So the first thing I need to do is to find the vertical asymptote. So vertical asymptote, I let this one equal to 0. So s minus 3 equal to 0 and s equal to 3, right? So if I graph it, original function is going to be something like this, right? And then this guy's 1, 2, and 3 right here. So vertical asymptote is going to be right here, s equal to 3. Alright, so now I look at this one, I need to do horizontal dilation first, b. So there is no horizontal dilation, I skip this one. Next one, horizontal translation, right? So actually the function f of s shifts 3 units to the right? Now next one, we're gonna talk about the vertical dilation, right? So there's no vertical dilation, but there is reflection right here, -1, right? So it's gonna be -1 in front of the output, which means reflect over the s-axis, right? And the last one, this one k equals -2. So this is the function f of s shifts down 2 units, right? Alright, so if you grab it, it's gonna be something like this. Alright, so for 3 different cases right here, you can use that most to check your answer. Now, let's move on to question number 1. The graph of the function f is shown above. Which of the following statements about f is correct? Alright, we know that the function f is decreasing, right? Because the rate of change is negative, right? If you draw the tangent line, it's going to be negative. Remember the Christmas tree trick, right? Right here, the slope is negative. Right here, the slope is positive, right? And the function is concave up, so the rate of change is increasing, right? Now, the function is decreasing, the rate of change is increasing. The answer must be C, right? Now let's move on to question number 2. The graph of the function g is shown above. Which of the following statements about the function g is correct? Alright, the function is concave up, which means the rate of change is increasing, right? Now we need to cross out b and d because it says the function is concave down, right? Now draw the tangent line, and you see that the slope is positive, which means the function is increasing, right? So the answer must be A. Now question 3. The logarithmic function h is defined by h of s equals -2 natural log of s, right? Which of the following statements about the function h is correct, right? Now we need to graph this one, right? So we have the parent function of the logarithmic function is going to be like this. Alright, now you multiply by -2 in front of the output, which means there is a dilation and reflection over the x-axis, right? So the final function should be something like this. Now this function is concave up, right, and decreasing, right? So the answer must be C. Now let's move on to question 4. The graph of the function k is shown above. Which of the following statements about the function k is correct? A. The rate of change of the function k is positive and increasing. Alright, so in order to know if it's positive or negative, we just draw the tangent line. And we see that the rate of change is negative, right? You just use the Christmas tree trick. This is negative, this is positive slope, right? So you're gonna cross out A and B. Right? Now, the rate of change is increasing or decreasing. We look at this one, we see that the function is concave up, which means the rate of change is increasing, right? So the answer is C. Now let's move on to question 5. The graph of f is shown above. Which of the following could be the equation of f, right? We know that this is the graph of the logarithmic function, right? So we need to eliminate C and D, right? Now, this is the parent function of the logarithmic function, which means there is no reflection at all, right? So the answer must be A. If the answer is B, it should be something like this. Reflect over the x-axis because we have the negative side right here, right? Now question 6. The logarithmic function L is defined by L of s equals negative 3 log base 4 of s. Which of the following pairs of statements correctly describe the end behavior of L, right? So we just get this one first, right? So we have the logarithmic function is going to be like this. Alright, now since you have the negative side right here, so there is a reflection over the x-axis, so it could be like this. Alright, so I need to erase this one. Alright, now I need to label positive infinitive right here. This is negative infinitive. This one is positive infinitive, and this one is negative infinitive, right? Now we're going to check the answer choice. Limit of the function L s when s approaches 0 plus, right? 0 plus, which means on the right hand side of the y-axis, right? So it could be right here. Right, the function approaches positive infinitive. This one say negative infinitive, so this wrong, right? Positive infinitive right here. So this wrong. Now the answer choice B. Limit of the function L of s when s approaches 0 plus, it could be positive infinitive, so this one right? Limit of the function L of s when s approaches positive infinitive. The function approaches negative infinitive. Yes, that's correct, right? So the answer B is correct. Now let's move on to question number 7. Let the function h of s equals 2 times natural log of s minus 3 minus 5. Which of the following gives the domain of the function h? Find the domain of the logarithmic function. Recall that log base a of b is defined when a greater than 0, a not equal to 1, and b greater than 0, right? Now since a is e, right, natural log is the same thing as log base e, right? So we don't need to worry about this guy anymore, right? We only worry about this guy right here. B greater than 0, which is the one inside parentheses. So s minus 3 must be greater than 0. Add triple sides of s greater than 3, right? So which means it's going to be from 3 to positive infinity, right? So the answer must be C. Now let's move on to question number 8. The graph of f is shown above. Which of the following statements about the function f is correct, right? Now the function f is increasing. No, the function f is decreasing, right? Because if you draw the tangent line, you see that the slope of the tangent line is negative, right? So the function is decreasing, right? So you need to cross out A and B, right? Now we need to check for the rate of change. Now because the function is concave down, which means the rate of change is decreasing, right? So the answer must be D. Now let's move on to question number 9. The logarithmic function k is defined by p of s equals 1/2 log s. Which of the following statements about the function p is correct, right? Now, we need to graph this one first, right? So, the function p of s can be graphed as follows. Now look at the answer choice A. The function p is increasing. Yes, because if you draw the tangent line and you see that the slope of the tangent line is positive, right? So the function is increasing. You need to eliminate C and D, right? The graph of the function p is concave up. No, this is concave down, right? So the answer must be B. Now let's move on to question 10. The value of the function k as shown in the table above at selected values of s. Determine if the function k could be linear, exponential, or logarithmic. Explain your reasoning. Now, in order to do this question, we need to determine the change in s and the change in y, right? Now, in order to get 6 from 2, we need to multiply by 3, right? This guy multiply by 3. This guy multiply by 3. The change in y is you need to add -2, right? This one add -2. And observe that the input values over the equivalent output values intervals are proportional, right? Because every single time you multiply by 3. So this is a logarithmic function, right? So this guy right here. Now let's move on to question 11. The function f is defined by f of s equals 3 times natural log of s. Which of the following could be the graph of f, right? So we know that the parent function of the logarithmic function is going to be like this, right? So because you have the positive 3 right here, so which means there is no reflection, right? So the answer must be A. Now let's move on to question 12. The logarithmic function f is defined by f of s equals 2 times natural log of s. Which of the following pairs of statements correctly describe the end behavior of the function f, right? So first we need to sketch this one, right? So the logarithmic function is going to be something like this. Look at the coefficient in front of natural log. There is no negative side, so there is no reflection, right? So we need to label this one positive infinitive. Now the answer choice A. Limit of the function f of s when s approaches 0 plus, which means on the right of the y-axis, right? So it could be right here, right? The function approaches negative infinitive. Yes, that's correct. It's going to be right here. Limit of the function f of s when s approaches positive infinitive. The function going up, right? Positive infinitive right here. So answer choice A, correct. Now let's move on to question 13. The function g is defined by g of s equals 3 times 2 to the s. Which of the following pairs of statements correctly describe the end behavior of g? Alright, so we need to sketch this one first, right? So we know that the exponential function is going to be y equals a times b to the s, right? If b greater than 1, it's going to be exponential growth, right? So in this situation, b equals 2, right? It's going to be exponential growth. So it could be something like this, right? Now look at the answer choice A. Limit of the function g of s when s approaches 0 plus, right? So this one is talking about the vertical asymptote, right? So vertical asymptote only apply for the logarithmic function, right? So this is exponential function. So you need to eliminate answer choice A and B, right? Now, answer choice C. Limit of the function g of s when s approaches negative infinitive. The function approaches the s-axis, right? Look at this one right here. So which means 0, right? So this one could be right? Limit of the function g of s when s approaches positive infinitive. The function approaches positive infinitive, right? So answer choice C is correct, right? Now question number 14. The function h is defined by h of s equals 5 times 2 over 3 of s. Which of the following pairs of statements correctly describe the end behavior of the function h? And you know that the exponential function y equals a times b to the s, right? A is positive and b greater than 0 less than 1, right? So this is an exponential decay function, right? So go ahead, get this one, right? So it could be something like this. Now let's take a look at the answer choice A and B right here. Limit of a function h of s when s approaches 0 plus, which is the vertical asymptote, right? So this one only applies for the logarithmic function, right? So we need to eliminate A and B, right? Now, answer choice C. Limit of a function h of s when s approaches negative infinity. The function approaches positive infinity, right? This say 0, so this wrong, right? Answer choice D. The limit of a function h of s when s approaches negative infinity. The function approaches positive infinity, so this is right. Limit of the function h of s when s approaches positive infinity, the function approaches 0, right? Because it's getting closer to the x-axis, right? So the answer choice must be D. Now, question number 15. The function f is defined by f of s equals negative 1/3 log s, right? Which of the following pairs of statements correctly describe the end behavior of the function f, right? So we need to get this one, right? So we know that the logarithmic function is going to be something like this, right? Now, since you have the negative coefficient right here, which means there is a reflection over the x-axis, so it could be something like this, right? Now, I need to eliminate the previous one, right? Now, answer choice A. Limit of the function f of s when s approaches 0 plus, which means on the right of the y-axis, the function approaches positive infinity, right? Now, it's a negative infinity, so it's wrong, right? Now, answer choice B. Limit of the function f of s when s approaches 0 plus, it could be positive infinity. Yes, that's correct, right? Now, limit of the function f of s when s approaches positive infinity equals negative infinity. Yes, that's correct, right? So the answer choice must be B. Now let's move on to question number 16. The function k is defined by k of s equals negative 1/2 times 3 to the s, right? So we need to get this one. Now we know that the exponential function y equals a times b raised to the s, right? B is 3 greater than 1, so this is exponential growth, right? So it should be something like this, right? Now, since a is negative, right? A equals negative 1/2, right? So there is a reflection over the x-axis, so the final one must be something like this, right? Now, limit of the function k of s when s approaches negative infinity. The function approaches 0, yes, because it's getting closer to the x-axis, right? Limit of the function k of s when s approaches positive infinity, right? This is positive infinity. The function approaches negative infinity, yes, it's going down, right? So the answer choice A is correct. Now let's move on to question number 17. The function h is defined by h of s is negative 4 times 1/3 raised to the s, right? Now we need to get this one, right? We know that b right here equals 1/3, so b greater than 0 less than 1. So this is a decay function, so it could be something like this, right? Now, since you have the negative 4 in front of the output, so there is a reflection over the x-axis, right? So it could be something like this. Alright, now look at the answer choice A. Limit of the function h of s when s approaches negative infinity. The function approaches negative infinity, so it's a 0 right here, which means this is wrong, right? Answer choice B. Limit of the function h of s when s approaches negative infinity. The function approaches negative infinity, right? It's a 0 right here, so it's wrong. Answer choice C. Limit of the function h of s when s approaches negative infinity equals negative infinity. Yes, that's correct, right? Limit of the function h of s when s approaches positive infinity. the function approaches 0, right? It's go to the right, the function getting closer to the x-axis, which means 0, right? So the answer choice must be C. Now let's move on to number 18. The function f is defined by f of s is negative 2 times 3 to the s, right? Now we need to sketch this one. We know that the exponential function y equals 3 to the s. It could be exponential growth function, right? So it could be something like this, right? Now since you have the negative 2 in front of the output, so there is a reflection over the x-axis, so it could be something like this, right? Now answer choice A. The function f is increasing. Alright, in order to know if it's increasing or decreasing, we need to draw the tangent line, right? So the tangent line is going down, which means the slope is negative, right? So the function is decreasing, so you need to eliminate A and B. Now answer choice C, the function f is decreasing, right? And the graph of f is concave down, right? This is concave up, so this is wrong. The answer choice must be D. Now number 19, the function g is defined by g of s equals 6 log s, right? So we need to get this one, right? We know that the log function is going to be something like this, right? Now answer choice A, the function g is increasing, right? We just draw the tangent line, and you see that the tangent line has the positive slope, so the function is increasing, right? So we need to eliminate C and D. Now the graph of g is concave down, right? This is concave up, so this is wrong, right? The answer choice must be B. Now question 20. The function h is defined by h of s equals 7 times 1/2 raised to the s, right? So we need to get this one first, right? So because b right here is less than 1 but greater than 0, right? So this is exponential decay function. So it could be something like this, right? Now the answer choice A. The function h is increasing. No, this is decreasing, right? Because you draw the tangent line, we see that the slope of the tangent line is negative, right? So you need to eliminate A and B, right? The graph of the function h is concave up, right? So this is concave up. The answer choice must be C. Now question 21. There is a typo right here, right? This is exponential function. The exponential function k is defined by k of s equals 2 times 4/3 raised to the s, right? So we need to get this one. Now we know that 4/3 is going to be greater than 1, right? So it could be exponential growth function. So it could be something like this, right? Now answer choice A. The function k is increasing. Yes. If you draw the tangent line, you see that the slope of the tangent line is positive, so the function is increasing, right? So we need to eliminate C and D. Now, the graph of k is concave up, right? So the answer must be A. Now, question number 22. The logarithmic function is defined by f of s equals negative 5 nat log of s, right? We need to get this one. Alright, you know that the parent function of the logarithmic function is going to be something like this, right? Now, since you have the negative 5 in front of the output, so there is a reflection over the x-axis, so it could be something like this, right? The function f is increasing or decreasing. You just draw the tangent line. You see that the tangent line is going down this way, which means the slope is negative, right? So the function is decreasing, right? So you need to eliminate A and B. Now, look at the rate of change. Because the function is concave up, right? So the rate of change is increasing, right? So this could be C right here. Now let's move on to question 23. The logarithmic function g is defined by g of s equals 3 times log base 5 of s, right? So the logarithmic function is going to be like this. Alright, so look at this one right here. The coefficient in front of log base 5 of s is positive, so there is no reflection, right? So it could be like this. Now, answer choice A. The function g is increasing, yes, right? Because you draw the tangent line, you see that the slope of the tangent line is positive, so the function g is increasing. So you need to eliminate C and D, right? Now look at the rate of change. The rate of change is increasing or decreasing. It's going to be decreasing because the function is concave down, right? So the answer must be B. Now let's move on to question 24. The function h is divided by h of s equals 4 times 2 to the s, right? So look at this one right here. This is an exponential growth function, right? Because b equals 2 greater than 1, right? So it could be something like this, right? Look at the coefficient right here. It's going to be positive, right? So there is no reflection, right? The function h of s is increasing, right? Because you draw a tangent line, the slope is positive, right? So the function is increasing. We need to eliminate C and D, right? Now look at the rate of change. Because the function is concave up, the rate of change must be increasing, right? So the answer choice must be A. Now let's look at the question 25. The function f is divided by f of s equals 6 times 1/2 raised to the s, right? Now observe that b right here is 1/2 less than 1, right? So it's going to be exponential decay function, right? So it could be something like this. Now since a is set positive, so there is no reflection, right? Now we need to know if the function is increasing or decreasing. Draw the tangent line, right? So the slope is negative. The function is decreasing, right? So eliminate A and B. Since the function is concave up, the rate of change is increasing, right? So the answer choice C is correct. Now number 26, the function k is divided by k of s equals negative 3 times 1/4 raised to the s, right? So we need to sketch this one. Alright, look at b right here. B equals 1/4, which is less than 1, right? So this is an exponential decay function, right? Now since a equals negative 3, so there is a reflection over the x-axis, right? So it's going to be something like this. Now look at the answer choice A. The function k is increasing. Now we need to draw the tangent line. And you see that the slope of the tangent line is positive. The function is increasing, right? So we need to eliminate C and D. We need to check for the rate of change, right? Since the function is concave down, the rate of change is decreasing, right? So the answer must be B. Now let's move on to question number 27. We need to sketch this graph, right? So we know that b is 3 greater than 1, right? So this is an exponential growth function, right? So it could be something like this. Now, since you have the negative coefficient in front of output, so there is a reflection over the x-axis, so it could be something like this, right? Now I need to erase the previous one, right? Now the function is decreasing, right? Because if you draw the tangent line, the slope is negative, so the function is decreasing, right? So we need to eliminate A and B, right? Now we need to check for the rate of change. Because the function is concave down, the rate of change is decreasing, right? So the answer must be D. Now since b equals 2 greater than 1, so this is exponential growth function, right? So it can be something like this. Now since a equals negative 5, so there is a reflection over the x-axis, so it's going to be something like this. Now in order to know if the function is increasing or decreasing, I'm going to draw the tangent line, right? And I know that the slope of the tangent line is negative, so the function is decreasing, right? So you need to eliminate A and B. Now the rate of change is decreasing, right? Because the function is concave down, right? So the answer must be D. Now question 29. we need to get this one. We know that the logarithmic function is going to be something like this, right? Now, look at the coefficient right here. It's going to be positive, so there is no reflection, right? Now, look at the answer choice right here. The function g is decreasing. We need to draw the tangent line. And we know that the tangent line is going this way, the slope is positive, so the function is increasing, right? So you need to eliminate A and B. Now, look at the rate of change. Because the function is concave down, the rate of change is decreasing, so the answer must be D. Now let's look at number 30. We need to sketch this one. Alright, so look at this one, you see that 2/3, which means b less than 1. This is exponential decay function, so it could be something like this, right? Now, in order to know if the function is increasing or decreasing, I'm going to draw the tangent line. So the tangent line is going down, the slope is negative, the function is decreasing, right? So I need to eliminate C and D. Now the rate of change is increasing because the function is concave up, right? So the answer must be A. Now number 31. The function h is defined -6 times log by 2 of s. So I must get this one. We know that the logarithmic function is to be something like this, right? Since a equals -6, so there is a reflection over the x-axis. So it could be something like this, right? Alright. Now, in order to know if the function is increasing or decreasing, we need to draw the tangent line. And you see that the tangent line is going down, right? The slope is negative, the function is decreasing. So you need to eliminate C and D. Now look at the rate of change right here. The function is concave up, the rate of change is increasing. So the answer must be A. Now question 32, we need to sketch this one. You know that the logarithmic function is going to be something like this, right? Look at the coefficient A right here. This is positive, right? So there is no reflection, right? Now, in this question, they just ask you about the rate of change only, right? So we just draw the tangent line only, right? So the slope of the tangent line is positive, right? So the rate of change is positive, right? We need to eliminate C and D, right? Now, since the function is concave down, the rate of change is decreasing, right? So the answer must be B. Now question 33, we need to sketch this one, so it could be like this. B equals 4 greater than 1, right? So it could be exponential growth function. It could be something like this. Now look at the coefficient A right here. It could be -3, right? So there is a reflection over the x-axis, so it could be something like this, right? The rate of change of the function f is positive or negative, right? We just draw the tangent line. And we see that the tangent line is going down, the slope is negative, right? So the rate of change is negative. We need to eliminate A and B. Alright, since the function is concave down, the rate of change is decreasing. So the answer must be D. Now look at number 34. We need to sketch this one. Alright, you know that the logarithmic function is to be something like this, right? Since a equals -2/3, so there is a reflection over the x-axis, right? So it could be something like this, right? Now I need to eliminate the previous one, right? Now the rate of change is positive or negative. We need to draw the tangent line. And you know that the tangent line is going this way, the slope is negative, right? We need to eliminate A and B, right? Now since the function is concave up, the rate of change is increasing, right? So the answer must be C. Now let's move on to the last two, 35 and 36. We need to sketch this one, right? Now b equals 3/5, which is less than 1. So this is an exponential decay function, right? Now since a equals 1, so there is no reflection, right? Now we need to check for the rate of change is positive or negative, right? Draw the tangent line. The tangent line is going down, the slope is negative. The rate of change is negative, right? So we need to eliminate A and B, right? Now, since the function is concave up, the rate of change is increasing, right? So the answer must be C. Now, number 36, the function k is negative 1/5 times 9 to the s, right? So we need to get this one. Because b equals 9 greater than 1. So this is an exponential growth function, so it can be something like this, right? Now, since a equals negative 1/5, which means there is a reflection over the x-axis, so it can be something like this, right? Now, I need to eliminate the previous one. Alright, in order to find the rate of change, I need to sketch the tangent line, right? So the tangent line is going down. The slope is negative, right? So I need to eliminate A and B. Now, because the function is concave down, the rate of change is decreasing, so the answer must be D. We're going to learn about the logarithm properties and logarithmic function manipulation. So look at the left hand side, we have the table of formulas right here. And the following errors that you need to get rid of. So don't apply these formulas. Alright. Now, example number 1, we need to condense its expression. Alright. So have the sum right here. I look at the first one. This is a product rule, right? Product becomes the sum, right? So this one I just go backwards over here. So it turns out to be log base 4 of x times y, right? Now this one right here, I look at the second formula right here. This is subtraction, right? So I convert it to quotient, right? So it could be log base 3 of 5 over z, right? Now the third one right here, I need to apply the first two right here. So I use the quotient rule, right? So it could be log base 10 of x over 5, right? And then I subtract log base 10 of z, right? Now I apply the quotient rule one more time. So it's going to be log base 10 of x over 5 divided by z. So I put z right here. Alright. Now question D. Before I apply the quotient rule, I need to print 3 back over here by using the formula right here. Alright. So I have log base 2 of x cubed minus log base 2 of y. Alright, so I'm going to apply the quotient rule. So it's going to be log base 2 of x cubed divided by y. Now next one. Alright, I still apply this formula right here, the power rule right here. Alright, I print 2 back over here. 5 go back over here, right? So I have log base 7 of a squared minus log base 7 of b power 5, right? And then plus log base 7 of 4. Right, so I apply the quotient rule right here. So I have log base 7 of a squared over b power 5 plus log base 7 of 4. Now I apply the product rule right here. So it's going to be log base 7 of 4 times a squared over b to the 5th. Right, now let's move on to the next one. So in order to condense this guy and this guy, I need to make this guy as log base 6, right? So I need to apply the formula right here. Alright, so basically 2, I just write log base of 6 square, right? Plus log base of s, and then I apply the product rule, right? So it's gonna be log base of 6 square times s, and then it's gonna be log base of 36 s, right? Now let's move on to the second example. Which of the following expressions is equivalent to this guy? Alright, so we need to expand this guy. Alright, so I use the quotient rule. So it's gonna be log base 3 of s squared minus log base 3 of y. Alright, so then I apply the formula right here, the power rule right here. So I'm going to print 2 to the front, right? So it's going to be 2 log base 3 of s minus log base 3 of y, right? Now I check the answer, so my answer should be C. Alright, now let's move on to the next 3 examples. Alright, example number 3. Given the function f of x equals log 6x. Alright, so if the function write like this, it means log base 10 of 6x, right? Is a horizontal dilation of the function g of x equals log x, which means log base 10 of x, shows that f can also be written as a vertical translation of g, with f of x equals g of x plus k, where k is a constant, right? So I just apply the product rule for f of x, so f of x is log 6 plus log x, right? And then I just rewrite this one as log x plus log 6, right? Log x, which means g of x, right? So I just replace log x with g of x, right? So this is g of x. And log 6 right here, this is a constant. So I just replace log 6 with k, right? And then this is f of x, right? So the function f of x equals the function g of x plus something. And then this is actually vertical translation by k units, right? Now let's move on to the example number 4. Let f of x equals log base 4 of x and g of x equals log base 9 of x. Show that f is a vertical dilation of g by finding the value of k, such that f of x equals k times g of x, right? So I start from the function f of x. It's gonna be log base 4 of x. Now I need to write this one in terms of g of x. So, but the function g of x is log base 9 of x. So I'm gonna apply the formula right here. Alright, this is called change of base rule. Right, so I look at the function g of x right here. I see that this is log base 9, right? So I need to write this one in terms of log base 9. So I just put a little 9 right here. Alright, so I just rewrite this one as log base 9. Now keep in mind, s above, 4 below. So I just write s right here first. Divide by log base 9. of 4, right? Alright, so this one I just rewrite as 1 over log base 9 of 4 times log base 9 of s, right? And then I just replace the whole thing right here with k, because this is a constant, right? So I have k times. Now this one right here, I just replace this one with g of s right here, right? So it could be g of s, right? So this is actually vertical dilation by a factor of 1 over log base 9 of 4. Now let's move on to the example number 5. Which of the following expression is equivalent to 3 natural log of x minus 4 natural log of y? Alright, so keep in mind, if we just write ln like this, which means log base e, alright? So this one right here, I just apply this power rule right here. Alright, so I just bring 3 back over here, 4 back over here. So I have natural log of x power 3 minus natural log of y power 4. And then I apply the quotient rule right here. Alright, so I have natural log of x power 3 over y power 4. And the answer is A. Now let's move on to the next example. We need to write its expressions as a sum or difference. So we're gonna apply the first formula and the second formula right here. Alright, so this one right here, we just write this one as log base 3 of x plus log base 3 of y power 3, right? Now we apply the formulas right here, the power rule right here. So we can bring 3 to the front, right? So it can be log base 3 of x, I just rewrite, plus 3 times log base 3 of y, right? Now this one right here, I just apply the quotient rule right here, right? So it's going to be natural log of x squared minus natural log of y cubed, right? So I can bring 2 to the front and 3 to the front. So it's gonna be 2 natural log of x minus 3 natural log of y, right? Now this one right here, you don't see the base, which means base 10, right? So if you see log only, which means log base 10, right? So this is log 1000 plus log s power 3, right? Now log 1000, I just write log base 10 of 1000, I just write 10 power 3, right? Plus log base 10 of s power 3. So I can bring 3 to the front, right? So it can be 3 log base 10 of 10 plus 3 log base 10 of s, right? So this guy equals 1. So I just write 3 plus this one right here, I just condense this, right? I just write 3 log s, right? I don't need to write base 10 because base 10 which means this one, right? Now question number 4 is going to be log base 2 of 8 plus log base 2 of square root of x, right? Now 8, I can rewrite this one as 2 power of 3, right? So it could be equal to log base 2 of 2 power of 3 plus log base 2 square root of x, I just write x power of 1/2, right? So this one 3 I bring it to the front, so it could be 3 log base 2 of 2 plus 1/2 bring to the front, so it could be 1/2 log base 2 of x. Now this guy is equal 1, right? So the answer is 3 plus 1/2 log base 2 of x. Now let's move on to question 5. So this one right here, before I'm gonna apply the quotient rule, I need to convert the radical sign into the exponent. So it could be log base 2 of 16x cubed over y squared altogether 1/2, right? So I can bring 1/2 to the front, right? So it could be 1/2 log base 2 of 16x cubed over y squared. Now I can apply the quotient rule. So it's gonna be, alright, so I'm gonna apply the product rule for this guy. So it's gonna be 1/2 parenthesis log base 2 of 16. Now I can write 16 as 2 power 4, right? So I have 2 power 4 right here. Alright, plus log base 2 of s cubed minus, now 2 right here I can bring it to the front, so it can be minus 2 log base 2 of y. Alright, so I just rewrite 1/2. 4 I bring it to the front, so it could be 4 log base 2 of 2 is going to be 1, so I don't need to write, right? Plus 3 bring it to the front, so it could be 3 log base 2 of x minus 2 log base 2 of y, right? Now question number 6, I need to factorize out, right? So it could be log base 3 of 9 of x minus 3, right? And then I apply the product rule, so it could be log base 3 of 9 plus log base 3 of x minus 3, right? And then 9 right here, I can rewrite 9 as 3 power of 2, right? So I bring 2 to the front, so it could be 2. And then I have log base 3 of 3 left, but log base 3 of 3 is going to be 1. So I don't need to write 1. Plus log base 3 of x minus 3, right? Now let's move on to the next one. So we need to condense this one. We're gonna apply the product rule right here. So it turns out to be natural log of 3 times x, right? Now number 8. Alright, so before we're gonna condense this one, we need to apply the power rule right here, right? So we just bring 2 back over here and 4 back over here. So it's gonna be log base 3 of x squared minus log base 3 of y power 4, right? And then we're gonna apply the quotient rule right here. So it's gonna be log base 3 of x squared over y power 4, right? Now this one right here, we're gonna distribute 1/2. So we have 1/2 log x plus 3.5 log y, right? Now we can bring 1/2 back over here and 3.5 back over here before we can condense them, right? So it's gonna be log x power of 1.5 plus log y power of 3.5, right? And then we're gonna apply the product rule right here, right? So it's gonna be log x power of 1/2 times y power of 3.5, right? And then we can write this one in the radical, right? So it's gonna be log square root of x times y power of 3 right here. Now the next one right here, we're gonna print 3 back over here, right? And 2 back over here. So we have log base 5 of s minus 4 power of 3 minus log base 5 of y square, right? So it's gonna be quotient rule, right? So it's gonna be log base 5 s minus 4 altogether power cube over y power square, right? Alright, next one, number 11 right here, we can use calculator, right? Now we need to apply the formula right here, change of base rule, right? So we can use base 10 or base e, right? Now we just put little 10 right here. So we have log base 10 of 123 divided by log base 10 of 4, right? Or we can use natural log, which means log by e, right? So we can write this one as natural log of 123 over natural log of 4, right? Now we can print up the calculator. Alright, so we just hit add calculator right here, and we hit control log right here. So base 10, we use base 10 of 123. Hit enter, and then hit division, control log base 10 of 4, and hit enter. And then you want to convert this one into decimal. Menu, number, convert to decimal, and hit enter. It's gonna be 3.471, right? So both give you the answer 3.471, right? Now question 12, you're gonna do similar, right? You're gonna do natural log, so it's gonna be natural log of 578 over natural log of 9, right? So you just hit the calculator. So natural log right here, hit control, natural log right here, 578, hit enter, divide by control natural log of 9, right? Hit enter. So then you want to convert this one into decimal, just hit menu, number, convert to decimal, hit enter. The answer is 2.894, right? Now question number 13, describe any transformation on the function, then find the domain and range of the transform function. Alright, so we're going to use the product rule. So f of s is going to be log base 4 of 16 plus log base 4 of s. So I rewrite log base 4 of s, and then log base 4 of 16, I just rewrite 16 as 4 square, right? So I bring 2 to the front, and then log base 4 of 4 is going to be 1, right? So this one I add 2, right? So this is actually vertical translation up 2 units from the function log base 4 of s to get the function log base 4 of 16s, right? Now the domain of this one is going to be, we look at this one right here. We see that the vertical asymptote right here s equal to 0, right? So it could be from 0 all the way to the right. So the domain is going to be 0, infinity. And the range is going to be always negative infinity to positive infinity, right? Alright, so look at number 14 right here. I'm going to use quotient rule, so it's going to be log base 2 of x minus log base 2 of 8, right? Now 8, I can rewrite 8 as 2 power of 3, right? So 3 I bring it to the front. So I have log base 2 of x minus 3. And I have log base 2 of 2 left. Log base 2 of 2 is equal 1. So this is actually vertical translation down 3 units from the function log base 2 of x to get the function g of x right here, right? And domain is the same thing as this guy, right? Because the vertical asymptote is x equal to 0. Now look at number 15 right here. You can bring 2 to the front, right? Because you're not going to use the power rule right here. So it's going to be f of x equals 2 times log base 5 of x. So you're going to multiply the output by a number. This is actually vertical dilation by a factor of 2. And you look at this one right here. The vertical asymptote is x equal to 0. So the domain is going to be 0 to infinity. And the range should be negative infinity to positive infinity. And the last one right here, number 16. So we have h of s right here. Now I'm going to factor 16 out. So it's going to be log base 2 of 16 times 2 minus s, right? And then I just rewrite this one as log base 2 of 16 plus log base 2 of 2 minus s. I factor negative 1 out, so it could be negative of s minus 2, right? So this one right here, 16, I just write 2 power of 4, right? And I bring 4 to the front. So I'm going to end up with 4 times log base 2 of 2, but log base 2 of 2 equals 1. So I just write 4 plus log base 2 of negative of s minus 2, like this, right? Alright, so I look at this one. I let this one equal to 0 right here. S minus 2 equal to 0. So s minus 2 equal to 0. S equal to 2. And this is your vertical asymptote, right? And you look at this one right here. You see the subtraction sign in front of the input, which means the function reflects over the y-axis. So when the function reflects over the y-axis, you're going to flip the domain. So the domain should be negative infinity to 2, right? You look at this one right here. Normally, if you don't have reflection, right, the domain should be from 0 to infinity. Now the domain should be negative infinity to 2, right? And the range is going to be same thing, negative infinity to positive infinity. If you grab this one using a calculator or decimal, you will see it. Now let's move on to the next one. So let x and y be positive constants. Which of the following is not equivalent to this guy, right? So we just apply the formula right here. The product rule, the quotient rule, and the power rule, right? So this one right here, I just rewrite log base 3 of x plus 3, right? And this one right here, I just print 2 to the back. So it could be plus log base 3 of x minus 1 altogether square, right? And this one subtract log base 3 of x plus 2, right? Alright, so I apply the product rule. I combine this guy. So it could be log base 3 of x plus 3 times x minus 1 altogether square, right? Subtract log base 3 of x plus 2, right? And then I apply the quotient rule. So it could be log base 3 of x plus 3 times x minus 1 altogether square over x plus 2, right? Now s minus 1 all together square, I can write this one as s minus 1 times s minus 1, right? Alright, so you need to read the question carefully. They say not. Alright, so look at B right here. B is equivalent, right? S minus 1 all together square is going to be the same thing as S minus 1 times S minus 1, right? And then B and C similar, right? Now D, you can apply the complete square formula. So S minus 1 all together square is going to be S square minus 2 times S times 1 and then plus 1 square, right? 1 square equals 1. So the answer D right here, correct, right? So the correct answer right here must be A, right? Because A is not equivalent, so the answer is A. Given log 3 equals x and log 4 equals y, which of the following expressions similar to log square root of 12, right? So I start from log square root of 12. I write this one as log square root of 3 times 4, right? So I just split this one, it's going to be log of square root of 3 times square root of 4, right? Now I'm going to apply the product rule. So it's going to be log square root of 3 plus log square root of 4, right? Now I convert the radical into the exponent. So it's going to be log 3 power of 1/2, right? Plus log 4 power of 1/2, right? So you can bring 1/2 to the front, so it could be 1/2 log 3 plus 1/2 log 4, right? Now log 3 equal x, so I just replace log 3 with x, so I have 1/2 x plus log 4 equals y, so I just replace log 4 with y, so I have 1/2 y. So I just factor 1/2 out, so I have x plus y inside, right? So the answer must be D, right? Now let's take a look at the last example. So I just rewrite log base b of 18 in terms of this guy right here, right? So I have log base b of 18 equals log base b of, now I need to factor 18, right? So 18 divided by 2 is going to be 9. 9 divided by 3 is going to be 3. 3 divided by 3 is going to be 1, right? So 18 can be written as this guy multiplied. So it could be 2 times 3 squared, right? So I apply the product rule. So it could be log base b of 2 plus log base b of 3 squared. Now 3 squared right here, I can bring 2 to the front, right? So it's going to be log base b of 2 plus 2 log base b of 3, right? Now I replace log base b of 2 with this guy right here. So it's going to be 0.4307 plus 2 times, I replace this guy with 0.687. So times 0.6827, right? And then I'm going to hit the calculator. The answer must be 1.7961. And we're going to learn how to solve the exponential and logarithmic inequalities. Alright, so look at the formula right here. If they have the same base, a to the f of s greater than a to the g of s, then we have two different cases. Case number 1, if the base greater than 1, and then you just have the inequality f of s greater than g of s. if the base greater than 0 less than 1, and then f of s less than g of s. Keep that in mind, the inequality switch, right? Now, if they have different bases, and then you need to take log both sides. If the base greater than 1, now depends on the base right here, right? So the base right here is a. You need to take log base a both sides, right? So log base a of a to the f of s greater than log base a of b to the g of s, and then you just print f of s to the front, and then you have log base a of a equals 1. So that's why you have f of s greater than g of s times log base a of b, because g of s you can bring to the front, right? Now if the base from 0 to 1, and then you do opposite, right? So basically you just switch the inequality symbol right here. Alright, so let's take a look at the example. 5 to the s plus s less than or equal to 25 raised to the s plus 1. Now we need to convert this one into the same base, right? So the left hand side I just rewrite 5 raised to the s square plus s less than or equal to 25 can be written as 5 square, right? So 5 square times s plus 1, right? And then this guy and this guy have the same base right here, and then because the base is 5 greater than 1, so I'm gonna apply this case right here. Alright, s square plus s less than or equal to 2 times s plus 1, right? Now you look at this one, this is greater than, and then this guy must greater than. Now original one less than or equal to, and then this guy must be less than or equal to, right? Now I'm going to distribute this one, it's going to be 2s plus 2, right? Rewrite the left hand side. Now I'm going to move every single thing to the left hand side, so it turns out to be s squared, subtract 2s both sides, and combine with s right here, so it turns out to be negative s, subtract 2 both sides, so it could be like this, less than or equal to 0, right? Now I'm going to use s method to factor this one. So I have c equals negative 2 and b equals negative 1. Now I need to find two integers, multiply equals negative 2, add up to negative 1, which is negative 2 and 1. So this one can be factor s minus 2 times s plus 1 less than or equal to 0. Now I need to find the 0 for each of these factors, right? So the first one, s minus 2 equal to 0, and then s equals 2. Now the second one, s plus 1 equal to 0, and then s equals negative 1. Alright, so I have the number line right here. Now I need to place negative 1 and 2 on the number line, right? So negative 1 go first because negative 1 less than 2, right? So I'm going to pick a number within this interval, right? The right hand side should be positive infinitive, the left hand side should be negative infinitive. Now I'm going to pick a number within this interval, right? So I'm going to pick 0. Right, so I'm going to substitute 0 into this inequality. So I have 0 minus 2 times 0 plus 1, right? It's going to be negative 2 times 1. It's going to be negative 2, which is less than 0. So this interval right here is going to be negative. Now I look at this one, I don't see any even multiplicity. So I keep changing the side, right? So this guy negative, this guy positive. This guy negative, this guy must be positive. Now, my goal is less than or equal to 0, right? So I only pick the negative interval, right? So negative interval is going to be from here to here, right? So it's going to be from negative 1 less than or equal to s less than or equal to 2, right? Because I have the equal sign right here. So this is my final answer. Or you can write this one as interval notation. It's going to be bracket negative 1, comma 2. Now let's move on to the next example. Given the function t of x equals 1 minus 4 times 2 raised to the s minus 3. We need to find all value of s such that the function t of x less than or equal to negative 31. Alright, we just let 1 minus 4 times 2 raised to the s minus 3 less than or equal to negative 31, right? So then I need to subtract 1 both sides. So it's going to be negative 4 times 2 raised to the s minus 3 less than or equal to negative 31 minus 1 is going to be negative 32. Now I need to divide both sides by negative 4. So it's going to be 2 raised to the s minus 3. When you multiply or divide both sides of the inequality, you need to switch inequality symbol. So this guy turns out to be greater than or equal to. Negative 32 divided by negative 4 is going to be 8, right? So 2 raised to the s minus 3 greater than or equal to 8 can be written as 2 power of 3, right? Now, this guy finds the first case right here because the base is 2 greater than 1, right? So we keep the same inequality symbol, right? So it's going to be s minus 3 greater than or equal to 3. Add 3 both sides, it's going to be s greater than or equal to 6. Or you can write bracket 6, comma, infinitive. And that is your solution. Now let's move on to the next example. Given the function h of s equals 1 over 3 raised to the 2 over s, and the function k of s equals 12 minus 3 times 1 over 3 raised to the 1 over s plus 1. Now find all value of s such that the function h of s greater than the function k of s. Alright, so we just substitute. So it's going to be 1 over 3 raised to the 2 over s greater than 12 minus 3 times 1 over 3 raised to the 1 over s plus 1. Alright, so you just move every single thing to the left hand side. So it's going to be 1 over 3 altogether raised to the 2 over s plus 3 times 1 over 3 raised to the 1 over s plus 1 minus 12 greater than 0. Now this guy can be written as 1 over 3 altogether raised to the 1 over s altogether power of 2, right? Plus 3 times 1 over 3 power of 1 over s plus 1 over 3 power of 1, right? Because I'm going to use the formula a to the m plus n. It's going to be a to the m times a to the n, right? Minus 12 greater than 0. Alright. Now this guy right here, I can simplify this guy and this guy, right? So this guy turns out to be 1 over 3 altogether raised to the power 1 over s altogether power of 2. Now this guy comes from this formula, a raised to the m altogether raised to the n. It's going to be a to the m times n, right? Plus 1 over 3 altogether raised to the 1 over s minus 12 greater than 0. Alright, so now I'm going to use chain of variable method. So it can be let a be 1 over 3 altogether raised to the 1 over s, right? And a must be greater than 0. Alright, so I'm going to substitute over here. So I have the equation a squared plus a minus 12 greater than 0. Now I'm going to factor this one out. So I'm going to use S method to factor this one. So I'm going to put C equals negative 12 and B equals 1, right? Now I need to find 2 integers multiply equal negative 12 add up to 1, which is 4 and negative 3, right? So this one can be factored as a plus 4 times a minus 3 greater than 0, right? So I need to find the 0 for this one. The 0 for this one is going to be negative 4. The 0 for this one is going to be 3. So I put negative 4 and 3 on the number line. Alright, the left hand side I put negative infinitive. The right hand side should be positive infinitive. Now I need to pick a number within this interval. So I pick 0, right? I substitute back over here. So I have 0 plus 4, 0 minus 3. So it turns out to be 4 times negative 3, which is negative 12, and it's going to be negative, right? So right here, it's going to be negative. And I look at this one right here, I don't see any even multiplicity. So the sign keep changing, right? So this guy negative, this guy turns out to be positive, and this guy is positive. Alright, so now I need the whole inequality greater than 0, right? So my answer should be this interval and this interval. But I don't take negative 4 and 3 because I don't have equal sign right here. So my answer must be negative infinitive, comma, negative 4. Union 3, comma, positive infinitive. Now I go back over here. I need to combine with the domain right here. Domain a greater than 0. Right? So this guy doesn't work because this guy less than 0. So I need to cross this one out. So my answer right here, a greater than 3, right? Because a from 3 to infinity, right? So I have a greater than 3, but a equals this one. So I substitute this guy back. So I have 1/3 altogether raised to the 1 over s greater than 3, right? Now 1/3 I can write 3 power of negative 1, right? Altogether raised to the 1 over s greater than 3, right? And then this power right here, I just use the formula right here. I'm going to multiply the power. So it can be 3 power of negative 1 over s greater than 3 right here. I can write 3 power of 1, right? Now I look at this formula right here. I see that a greater than 1. So I keep the same inequality direction, right? So I just have negative 1 over s. Keep the same, this guy greater than 1, right? This guy greater than this guy. So I'm going to multiply both sides by s. It's going to be negative 1 greater than s, right? Or s less than -1. Now, I'm going to subtract 1 both sides, so it can be -1 over s subtract 1 greater than 0, right? So I'm going to multiply both sides by -1. It's going to be 1 over s plus 1 less than 0, right? So I need to rewrite this one and this one in the same denominator. So it's going to be 1 plus this 1 I can write as s over s, right? So it could be 1 plus s over s less than 0, right? So I need to solve this inequality. So I need to find the 0 on the numerator. 1 plus s equal to 0. So then s equals -1. And then the bottom s equal to 0, right? So I have 2 0, -1 and 0. I put these 2 0 on the number line. So -1 go first and then 0 go right here. And then the left hand side should be negative infinitive. The right hand side should be positive infinitive, right? And then I need to pick a number in this interval. So I put 1 right here. I substitute over here, right? So I have 1 plus 1 over 1 is going to be positive, right? So this guy positive. And then I don't see any even multiplicity, so I keep changing the sign. So it could be negative and this guy positive. Now I need this inequality, right? Less than 0, right? So I only need this guy right here, right? So it could be -1 less than s less than 0 is the final answer. Now let's move on to the next example. For example, we need to solve 2 raised to the s plus 2025 greater than 2025. Alright, so we look at this one right here. We see that this guy and this guy cannot be the same base, right? So I'm going to use this one right here, this case. Alright, because the base is 2, right? Greater than 1, right? So then I take log base 2 both sides. So I have log base 2 and this guy log base 2, right? And then I keep the same inequality symbol right here. And then this guy turns out to be 2 raised to the s plus 2025. And this guy 2025, right? Now you have the formula log base a of b power of m. So you can bring m to the front. This guy turns out to be m log base a of b. Now if you have log base a of a, it's going to be equal to 1, right? So this guy turns out to be, bring this guy to the front, it's going to be s plus 2025 times log base 2 of 2. But log base 2 of 2 is going to be equal to 1, right? So I don't need to write this one. Greater than log base 2 of 2025, right? So I just subtract 2025 both sides. So s greater than log base 2 of 2025 subtract 2025. Now this guy and this guy you cannot simplify. Don't take 2025 subtract 2025. That's wrong, okay? So you just leave the answer like this. And this is the final answer. Now let's move on to the next example. For example, we need to solve 1 over 2 all together raised to the s plus 2 greater than 3. Alright, so we look at this one, we see that the base is 1/2 less than 1. And this guy, they are different base, right? So we're gonna apply this case right here. Alright, so I'm gonna take log base 1/2 both sides. So I have log base 1/2, and this guy log base 1/2, right? And then I have 1/2 raised to the s plus 2. For this one right here, you need to switch inequality symbol. So this guy turns out to be less than. Alright, and then it's gonna be 3 right here. Alright, so I bring s plus 2 to the front. And then this guy turns out to be log base 1/2 of 1/2, right? Less than log base 1/2 of 3, right? Now this guy equals 1, right? Based on the formula right here. So it's gonna be s plus 2 less than log base 1/2 of 3. Now you subtract 2 both sides, so it's gonna be s less than log base 1/2 of 3 minus 2. Now if you want to simplify this one further, you just rewrite 1/2 as 2 power of negative 1. So this guy turns out to be s less than log base 2 power of negative 1 of 3 minus 2, right? And then negative 1 bring to the front is going to be 1 over negative 1, right? So s less than negative log base 2 of 3 minus 2. And this is the final answer. Now let's move on to the next one. Logarithmic inequalities. Alright, so basically we do exactly the same thing as we did in the exponential inequalities. So for example, if I have, now first I need to find the domain. So then in this situation, this guy is b, and it b greater than 0, right? So I have s plus 1 times s plus 2 greater than 0, right? And then I need to find the 0 of each of these factors right here. So s plus 1 greater than 0. And then s greater than negative 1. S plus 2 greater than 0. Then s greater than negative 2, right? So then I need to put this guy on the number line. So I have negative 2, negative 1. Alright, so I need to pick a 0 in this interval right here. Alright, so I substitute over here. So I have 0 plus 1 is going to be 1, 0 plus 2 is going to be 2, 1 times 2 is going to be 2. So this guy is positive. So because I don't have any even multiplicity, so I keep changing the sign, right? So this guy is positive right here. Alright, so this is positive infinitive, this guy is negative infinitive, right? Now, I need this guy to be greater than 0, so the interval right here and right here, right? So it could be negative infinitive 2, negative 2, union negative 1, 2, infinitive, right? Alright, so this guy 1 can be written as log base 2 of 2, right? So we look at this one, this guy and this guy have the same base and greater than 1. So we're gonna apply this formula right here. So I have s plus 1 times s plus 2 less than or equal to 2, right? Now I need to distribute this one, so it could be s squared plus 2s plus s plus 2, and then I subtract 2 both sides, right? Less than or equal to 0. Alright, so s squared 2s plus s could be 3s, right? And then 2 minus 2 is could be 0, so this guy less than or equal to 0, right? So I factor s out, right? So it could be s plus 3 less than or equal to 0, right? So I need to find the 0 of each of this factor right here. So s equal to 0, and the second one s plus 3 equal to 0, and then s equals negative 3, right? So I need to draw a number line, and then I'm going to put 2 zeros on the number line. So negative 3 right here and 0 right here, right? And this is positive infinitive, this is negative infinitive. I put a line right here, right? So I need to pick a number within this interval, so I pick a number 1 right here. So I substitute over here, so I have 1 times 1 plus 3, right? 1 plus 3 equals 4. 4 times 1, it could be 4. So this is positive, right? So positive. And since I don't see any even multiplicity, so I keep changing the sign, right? So it's negative and this is positive, right? Now, finally, I need this one to be less than or equal to 0, right? So it's going to be right here, right? So the answer for this one is going to be negative 3 to 0, right? Now, since we have equal signs, so we need to include negative 3 and 0, right? So now we need to compare the answer and the domain, right? So we need to draw this guy, right? So we need to put the negative 3 right here, negative 2 right here, negative 1 and 0. This guy is positive infinitive, this guy is negative infinitive. Now I need to check the domain first. Negative infinitive to negative 2, right? So I need to eliminate this one, and from negative 1 to infinitive, right? So this guy is my domain, right? Now the answer right here, negative 3 to 0, right? So I need to eliminate this interval, right? And I need to eliminate this interval, right? So only this guy satisfied, right? This guy and this guy right here. So my final answer must be negative 3. We need to include negative 3, right? So it's going to be negative 3 comma negative 2, right? We're not going to include negative 2, right? Look at this one. Union negative 1 not included, right? Comma 0, 0 included right here. And this is the final answer. Now let's move on to the next example. So log base 1/3 of s plus 1 less than or equal to log base 3 of 2 minus s. And we see that this guy have different base. So it's fall into this case right here. Now we need to convert it to the same base, right? 1/3 we can write as log base 3 power of negative 1, right? Of s plus 1 less than or equal to log base 3 of 2 minus s, right? And then I have the formula log base a to the m of b. I can bring m to the front, so it's going to be 1 over m log base a of b, right? So negative 1 bring to the front, so it could be negative 1 over 1, which means negative 1, right? Log base 3 of s plus 1 less than or equal to log base 3 of 2 minus s, right? Now negative 1 you can bring it back over here by using the formula m log base a of b, right? You can bring m back over here, so it will be log base a of b raised to the m, right? So this guy turns out to be log base 3 of s plus 1 power of negative 1 less than or equal to log base 3 of 2 minus s, right? And then s plus 1 power of negative 1 turns out to be 1 over s plus 1, right? So this guy turns out to be log base 3 of 1 over s plus 1 less than or equal to log base 3 of 2 minus s, right? And then this guy have the same base 3, right? So this guy base 3 greater than 1, right? So we just keep the same direction right here. So we have 1 over s plus 1 less than or equal to 2 minus s, right? And then this guy must be greater than 0, right? Look at this one. because the domain of this one must be greater than 0, right? So I need to solve the left hand side first, right? So 1 over s plus 1 greater than 0, right? So the top already greater than 0, so I need s plus 1 greater than 0, right? So then s greater than -1. This is my domain. Okay, now I need to solve for 1 over s plus 1 less than or equal to 2 minus s, right? So I need to subtract 2 and add s both sides. So this guy turns out to be 1 over s plus 1 minus 2 plus s less than or equal to 0, right? So I need to write this one the same base, right? By multiplying this one by s plus 1, this guy by s plus 1, right? So I have 1 minus 2 times s plus 1 plus s times s plus 1 all together over s plus 1 less than or equal to 0, right? So I need to simplify this one. It's going to be 1 minus 2s minus 2 plus s squared plus s over s plus 1 less than or equal to 0, right? So this guy turns out to be s squared minus s minus 1 over s plus 1 less than or equal to 0. Now observe that the domain is s greater than -1 is the same thing as s plus 1 greater than 0. So this one already greater than 0. In order for the whole thing right here less than or equal to 0, the numerator must be less than or equal to 0. So I only need s squared minus s minus 1 less than or equal to 0. So I need to use quadratic formula to solve this one because I cannot factor this one, right? So I have s1, s2 equals negative b plus minus square root of b squared minus 4ac over 2a, right? And then this guy turns out to be negative b, which means b equals -1. So it will be 1 plus and minus square root of 1 minus 4 times a equal to 1. And c equals -1, right? Over 2a, 2 times 1, right? So this guy turns out to be 1 plus and minus square root of 5 over 2, right? So I have two solutions and I need to put this guy on the number line, right? So the first one is going to be 1 minus square root of 5 over 2, and the other one 1 plus square root of 5 over 2, right? And then I need to put a line right here. Now I need to pick a number, right? Within this guy and this guy I pick a 0, right? So I put 0 over here. So I have 0 squared is going to be 0, minus 0 is going to be 0. So I have -1, which is negative side, right? This guy positive, this guy positive, right? So in order for this guy to be less than or equal to 0, I need this interval right here, right? So it can be 1 minus square root of 5 over 2. Because I have the equal sign, so I need to pick this one, right? Comma 1 plus square root of 5 over 2. And this is my final answer. Alright, let's move on to the next example. Given the function f of s equals log of s squared minus 4s plus 7 minus log of s plus 3. We need to find the value of s such that f of s greater than 0, right? So, we need to find the domain, right? So domain is going to be s squared minus 4s plus 7 greater than 0 and s plus 3 greater than 0, right? So I have the inequality because f of s greater than 0. So does that mean we have log of x squared minus 4x plus 7 minus log of x plus 3 greater than 0. Alright, so I use the logarithmic property to condense this one. Right, so it turns out to be log of x squared minus 4x plus 7 over x plus 3 greater than 0. Right, now 0 can be written as log 1, right? So then I have x squared minus 4x plus 7 over x plus 3 greater than 1 because the base is 10, right? Already greater than 1, right? So this guy can be written as x squared minus 4x plus 7 over x plus 3 minus 1 greater than 0, right? And then I need to write this one the same denominator, so basically I multiply this one. So it turns out to be x squared minus 4x plus 7. Negative 1 times x is going to be negative x. Negative 1 times 3 is going to be negative 3 over x plus 3 greater than 0, right? Now I look at the domain right here. X plus 3 must be greater than 0, right? So the bottom right here, of course, already greater than 0, right? So I need the numerator greater than 0. That's it, right? So I need to simplify the numerator. So it could be x squared minus 5x plus 4 greater than 0, right? So I need to factor this one out. So it turns out to be x minus 4 times x minus 1 greater than 0, right? So I need to put 2 zeros on the number line, right? So the zero of this one should be x minus 4 equal to 0. Then x equals 4, right? X minus 1 equals 0. And then x equals 1, right? So I put 1 and 4 on the number line. Right, this is negative infinitive and this guy is positive infinitive, right? Now I need to pick a 0 right here. I substitute over here. So 0 minus 4 is going to be negative 4. 0 minus 1 is going to be negative 1. Multiply this one should be positive, so this guy is positive. Now there is no even multiplicity, so this is keep changing the signs, right? Negative, positive, right? Now I need this guy to be greater than 0, right? So my solution should be this guy and this guy right here, right? So solution should be negative infinitive, comma 1. Union 4, comma positive infinitive, right? But we look at this one right here because the domain is s greater than negative 3, right? So we need to combine this guy with the domain, right? Because negative 3 is going to be in the middle right here. Negative infinitive to negative 3, negative 3 to 1. Right, so the final solution must be negative 3, comma 1. Union 4, comma positive infinitive. Topics 2.13 to 2.15 logarithmic equation and semi-log plus. Alright, so part 1, no calculators. Solve the following equations. Now, remember that log base a of b is defined when a greater than 0, a not equal to 1, and b greater than 0. So, before you're going to solve the logarithmic equation, you need to find the domain. Alright, so the domain of this one should be s minus 1 greater than 0. so s greater than 1, right? Now we're going to solve this one. We know that log base a of b equals c. Then a power of c equals b, right? So you just draw the arrow right here. So you have s minus 1 equals 10 power of 2, right? So 10 power of 2, it could be 100, right? Now you're going to add 1 both sides, so s equals 101. Now you're going to check this one with the domain, right? 101 greater than 1. So s equals 101 is the solution, right? Now number 2, you need to find the domain, right? So the domain 2s greater than 0. Divide both sides by 2. So then s greater than 0, right? Now you need to divide both sides by 4. So you have log base 3 of 2s equals 2. Now you're going to draw the arrow, so you have 2s equals 3 squared, right? 3 squared equals 9, right? Now you need to divide both sides by 2, so s equals 9 half, right? So this is the solution because it's greater than 0, right? Now number 3, the domain s over 3 greater than 0. So then s greater than 0, right? Now, natural log of s over 3 is the same thing as log base e of s over 3, right? Now you need to subtract 4 both sides, so it turns out to be 3, right? Now I'm going to draw the arrow. So I have s over 3 equals e cubed, right? Now I need to multiply both sides by 3. So s equals 3 times e cubed, right? Now this one is a solution because it's greater than 0, right? Now let's move on to number 4. We need to find the domain, right? So this one must be greater than 0 and this one must be greater than 0, right? So I have s greater than 0 and s minus 4 greater than 0. Now I need to solve a system of inequality right here. So I have s greater than 0 and s greater than 4, right? So I'm going to combine this guy right here. So I have s greater than 4, right? Alright, now I need to condense this one, right? I know that log base a of b minus log base a of c is the same thing as log base a of b over c, right? Now this guy turns out to be log base 10 of s over 3 equals log base 10 of s minus 4, right? Now both sides have the same log base 10, right? So I just equate this one and this one, right? So I have s over 3 equals s minus 4, right? Now I'm going to multiply both sides by 3, so I have s equals 3s minus 12, right? Now subtract 3s both sides, so I have negative 2s equals negative 12. And divide both sides by negative 2, so s equals 6, right? Now check the domain. S equals 6 greater than 4, so this is a solution, right? Now, number 6 similar to number 4, so I'm going to solve number 6 before number 5, right? So I need to find the domain first, so 4s greater than 0 and s minus 2 greater than 0, right? Now I need to solve a system of inequalities right here, so s greater than 0 and this one s greater than 2, right? Now I need to combine two inequalities, so I have s greater than 2, right? Now I need to condense this one by using the formula in the example number 4, right? So I have log base 2 of 4s divided by s minus 2 equals 3, right? And then I'm going to draw the arrow like this. So it turns out to be 4s over s minus 2 equals 2 power of 3. It's going to be 8, right? Now I'm going to multiply both sides by s minus 2. So I have 4s equals 8s minus 16, right? Now I need to subtract 8s both sides, so I have negative 4s equals negative 16, and then divide both sides by negative 4, so s equals 4, right? Now I'm going to check the domain. This guy greater than 2, so this is a solution. Now let's move on to number 5. I need to find the domain first, right? So I have a system of inequalities s plus 2 greater than 0, s minus 1 greater than 0, and 3s plus 13 greater than 0, right? And I solve this one, so it turns out to be s greater than negative 2, s greater than 1, and s greater than negative 13 over 3, right? So I need to combine this one. It turns out to be s greater than 1 is the final domain, right? Now I need to condense this one by using the formula log base a of b plus log base a of c equals log base a of b times c, right? Now I need to apply the formula right here to condense this one, so it turns out to be natural log of s plus 2 times s minus 1 equals natural log of 3s plus 13, right? Now both sides have the same natural log, so I just equate this guy and this guy, right? So now I just distribute this one, right? So it turns out to be s squared minus s plus 2s could be plus s, right? Minus 2 equals 3s plus 13, right? Now I move every single thing right here over, right? So it turns out to be s squared 3s, bring it over here, it could be negative 3s, so it turns out to be negative 2s, right? 13, move it over here, so it could be negative 13, so negative 15 equals 0, right? Now I need to factor this one using the s method, right? I need to find 2 integers multiply equals negative 15 and add up to negative 2, which is negative 5 and 3, right? So this guy turns out to be s minus 5 times s plus 3, right? Equals 0. And then this is a 0 product, so s minus 5 equals 0 or s plus 3 equals 0. And then s equals 5, s equals negative 3, right? Now I need to check the domain. The domain is s greater than 1, so only one solution right here, right? This is not a solution, right? So be careful. Now number 7 similar to number 5, right? So I need to find the domain, right? So I have a system of two inequalities, right? So I have s greater than 0 and 2s plus 13 greater than 0, right? So it turns out to be s greater than 0 and s greater than negative 13 over 2. And finally, unit s greater than 0 is the final domain, right? Now I need to condense this one using the formula right here. Before I condense this one, I need to bring 2 back over here, right? I'm going to use the formula k log base a of b equals, bring it over here, so it could be log base a of b power of k, right? So keep that in mind. Now this guy turns out to be natural log of s plus natural log of 3 squared, right? Equals natural log of 2s plus 13, right? Now I'm going to condense this one using the formula right here. So I have natural log of 3 squared equals 9, right? So I have 9s equals natural log of 2s plus 13, right? Now I need to equate this guy and this guy, right? Because they have the same natural log, right? So it could be 9s equals 2s plus 13, right? Now subtract 2s both sides, so I have 7s equals 13, right? Divide both sides by 7, so s equals 13 over 7, right? This one greater than 0, right? Because the domain right here greater than 0. So this is a solution. Now let's move on to question number 8. Given two functions fs and gfs. Now first we need to find the domain of these two functions, right? So I need to find the domain of the function fs first, right? So it's going to be s minus 3 greater than 0, right? Add 3 both sides, so s greater than 3, right? Now the domain for the function g of s is going to be s plus 2 greater than 0, right? So s greater than negative 2, right? Alright, now question A. Solve for fs equals 1 for value of s in the domain of f, right? So fs equals 1, which means 1/2 log base 10 of s minus 3 equals 1, right? Multiply both sides by 2, right? So it turns out to be log base 10 of s minus 3 equals 2, right? Now I'm going to draw the arrow, right? So I have s minus 3 equals 10 square, right? 10 square equals 100, right? Now I need to add 3 both sides, so s equals 103, right? 103 greater than 3 right here. So this is a solution, right? Now question B. Solve for GLS equal 8, right? So I have 3 natural log of s plus 2 equals 8, right? Now I need to divide both sides by 3. So I have natural log of s plus 2 equals 8 divided by 3, right? Natural log is the same thing as log base e of s plus 2, right? Equals 8 over 3, right? Now I need to draw the arrow, right? So it turns out to be s plus 2 equals e raised to the 8 over 3, right? Now I need to subtract 2 both sides, so s equals e raised to the 8 over 3 minus 2, right? Now look at the domain right here. We need s greater than negative 2, right? This one actually greater than negative 2, right? So this is a solution. Now question 9. The function j and k are given by these two guys, right? Rewrite j of s as a single natural logarithm without negative exponent in any part of the expression. Alright. Your result should be of the form natural log expression. Alright. Alright, so these are key information you need to keep in mind, right? Now j of s is going to be 1 over 3 natural log of s minus 4 natural log of y, right? Now you can print this guy back, right? Print this guy back over here. Remember, log base a of b. You have k in the front, you can print k back over here. So it can be log base a of b raised to the power of k, right? So this guy turns out to be natural log of s power of 1/3, right? Minus natural log of y power of 4, right? Now I'm going to use the formula log base a of b minus log base a of c equals log base a of b over c, right? Now natural log, which means log base e, right? Alright, so I can condense this one using the formula on the right hand side right here. So it turns out to be natural log of s power of 1/3 divided by y power of 4, right? You can leave your answer like this, or you can convert it to radical, right? So s power 1/3 is the same thing as natural log of cube root of s over y power of 4. Now, right? Now you're going to check to see if you satisfy the condition right here without negative exponent, right? You don't have negative exponent. Your result should be of the form natural log and expression. Yes, that's correct, right? This is natural log and expression. So this is the final answer. Alright, this question you're going to see mostly on the AP exam for the free response question. Now question B. rewrite k of s as a single logarithm base 10 without negative exponent, right? Your result should be in this form, right? Alright, so k of s right here, I'm going to copy over here. So it turns out to be 3 log base 10 of s plus 2 minus log base 10 of s plus log base 10 of 5, right? Now, I'm going to use the formula right here. I'm going to bring 3 back over here, right? So it turns out to be log base 10 of s plus 2 q, right? Minus log base 10 of s plus log base 10 of 5, right? Now I'm going to use this formula right here to condense the first two right here. So it turns out to be log base 10 of s plus 2q over s, right? And then plus log base 10 of 5, right? Now I'm going to use the formula log base a of b plus log base a of c equals log base a of b times c, right? So I'm going to condense this one. So it turns out to be log base 10 of 5 times s plus 2q over s. And this is the final answer, right? It satisfies this guy right here and without negative exponent right here, right? Now let's move on to number 10. Given a function k of s right here, solve for k of s equals 7e for value of s in the domain of k, right? This is the exponential function, so the domain should be all real numbers, right? Now we have 2 times e raised to the 3s minus e equals 7e, right? I'm going to add e both sides, so I have 2e raised to the 3s equals 8e, right? Now divide both sides by 2, so it turns out to be e raised to the 3s equals 4e, right? Now I'm going to take natural log both sides, so I have natural log of e raised to the 3s equals natural log of 4e, right? Now for this one, I just bring 3s to the front, right? So I have 3s natural log of e equals natural log of 4e, right? Now I'm going to divide both sides by 3 natural log of e, right? Because I need to solve for s, right? So s equals natural log of 4e divided by 3 natural log of e, right? Now I need to simplify this one, so I'm gonna expand this one using the formula right here. Alright, the product becomes the sum, right? So it could be natural log of 4 plus natural log of e over natural log of e equals 1, right? So it's gonna be 3, right? Now natural log of e equals 1, right? So this guy turns out to be natural log of 4 plus 1 over 3. This is the final solution. Now let's move on to number 11. What are all values of s for which h raised to the 2s plus 1 equals 1 4, right? We need to make this equation have the same base both sides, right? So h right here I can write as 2 power 3, right? Times 2s plus 1, right? This one right here I can write as 1 over 2 square, right? Now 2 square I can bring to the top. It turns out to be 2 power of negative 2, right? Now I need to equate the exponent, right? This guy equals this guy because they have the same base 2, right? So it could be 3 times 2s plus 1 equals negative 2. Now I need to distribute this one, so it could be 6s plus 3 equals negative 2, right? Subtract 3 both sides, so 6s equals negative 5, right? So s equals negative 5 over 6, right? This is the solution. Now let's move on to question number 12. This one is calculator active, right? So we can use the calculator to do this problem, right? Now, starting in 2018, a biologist studied the population of largemouth bass in a particular lake over several years. In 2019, which means t equals 1, there were 430 largemouth bass in the lake. In 2023, which means t equals 5, there were 715 largemouth bass in the lake. The number of largemouth bass in the lake can be modeled by the function L, given by L of t equals a plus b natural log of t, where Lt is the number of largemouth bass in the lake during the year t, and t is the number of years since 2018, right? Question A. Use the given data to write two equations that can be used to find the values for the constant a and b in the expression for Lt, right? So you have equation right here. Now t equals 1, you have this guy, right? So you have L1 equals a plus b natural log of 1, and then this guy equals 430, right? The second equation, L5 right here, equals a plus b natural log of 5 equals 715 right here, right? Now question 2, find the values of a and b, right? So from this system of two equations right here, I have a plus b times natural log of 1. Natural log of 1 equals 0, right? So this guy turns out to be a equals 430, right? Now second equation, you have a plus b natural log of 5 equals 715, right? So you substitute 430 for a in this equation, right? So you have 430 plus b natural log of 5 equals 715, right? Now subtract 430 both sides, so you have b natural log of 5 equals 715 subtract 430. It's gonna be 285, right? Now divide both sides by natural log of 5, so b equals 285 divided by natural log of 5, right? Now you can bring up the calculator, so you have 285 divided by natural log of 5. It's gonna be 177.08, right? Now question B. Use the given data to find the average rate of change of the number of largemouth bass in the lake in fish per year from t equals 1 to t equals 5 years. Express your answer as a decimal approximation. So recall that the average rate of change formula is going to be f of b minus f of a over b minus a, right? Now in this situation, it's going to be L, right? So I'm going to use L right here. So it can be LB, which means right here 5, right? L5 subtract L1, right? L1 right here. Divide by 5 minus 1, right? Now L5, I got it right here. 715, right? So I have 715 subtract L1, I got it right here. 430 over 5 minus 1, right? So this guy turns out to be 285 divided by 4, right? So it's going to be 71.25, right? Question 2 right here. Interpret the meaning of your answers from I in the context of the problem. Alright, so this is the average rate of change right here. So we're going to say that from 2019 to 2023, the population of large mouse increased at a rate of 71.25 parts per year. Now question 3. Consider the average rate of change of the function L from t equal 5 to t equal b years, where p greater than 5. And this average rate of change less than or greater than the average rate of change from t equal 1 to t equal 5 years found in 1. Explain your reasoning. Alright, so this guy right here, we got it right here, 71.25. Now, they ask us to determine if the average rate of change from t equal 5 to t equal p, where p greater than 5, is greater than or less than 71.25, right? So we're going to use the calculator to graph this function, right? Now, before we graph the function, we need to write the function first, right? So the function is going to be right here. LT equals A plus B natural log of t, right? So I have LT equals A plus B times natural log of t, right? Now, A equals 430, right? B equals this guy right here, right? Or you can use this one, 285 over natural log of 5, right? So this guy turns out to be 430 plus 285 over natural log of 5. Remember that this one is a constant, right? And natural log of t right here, right? Now I'm going to bring up the calculator. So I'm going to hit add graph right here, right? So I'm going to put the function right here. So I hit enter. Now I need to adjust the window range, right? So I need to hit menu, window, zoom, and hit window setting right here. Alright, so as mean, I'm going to put 0. As mass, I'm going to put 10. The scale is auto, right? Y mean, I'm going to put negative 5. Y mass, I'm going to put 1000. Alright, hit OK. It's going to be like this, right? And observe that the function is concave down, right? Now, I'm going to sketch this one over here. The average rate of change of the function L from t equals 5, this is 5 right here, to t equals p, so p is somewhere else right here because p is greater than 5, right? So it's going to be something like this. Alright, now the average rate of change of the function L from t equal 5 to t equal p are going to be less than the average rate of change from t equals 1 to t equals 5, right? Because the function L is concave down, so the average rate of change is decreasing, right? Now let's move on to question number 13. The table above gives selected values of the life expectancy in years and income in $1,000 per year for individuals around the world. The data in the table can be modeled by the function L of s equals A plus B natural log of s, where s is the individual income in $1,000 per year, and L is the predicted life expectancies in years. Find the equation of L of s using the regression features of your graphing calculator. Alright, so I'm going to use 3 different methods: TI and SPY calculator, TI-84 plus CE calculator, and Desmos. Alright, first I'm going to bring up the calculator right here. Alright, so I need to go to home screen, right? I need to hit spreadsheet right here, right? I need to name the first column, it's going to be S. The second column should be Y, right? Now I need to input the values for this table, right? Alright, now I need to move my cursor to the right column of Y columns, right? So it's gonna be right here. Alright, so I need to hit menu, number 4 statistic, number 1 start calculation, and I need to find the logarithmic expression, right? So I need to go down, it's gonna be right here, B, right? Now this one I need to name as should be Y, right? Now it's gonna be this one right here. Alright, so the equation should be L of S equals 56.8135 plus 6.5338 natural log of S, right? Now, if I'm going to use the TI-84 plus C calculator, I just hit start right here. Add it. Now L1, which means the first column right here. Remember, this one is S and this one is Y, right? So I just input the values for this table, right? Alright, so now I'm going to hit start again. Go to count. Find the logarithmic expression. Now hit number 9. Logarithmic regression, right? L1 is the S column. L2 is the Y column. Go to store right here. Hit vars, Y vars, function Y1 so that the calculator save our equation as Y1 for later use, right? Calculate. Alright, so it can be like this. It's exactly the same thing right here, right? Alright, so you can use that most. You just hit the plus sign right here. Alright, table. Now you just input the values for this table. Alright, now you hit the 4 dots right here. And then you need to choose logarithmic regression. It's gonna be right here. Alright, make sure you need to put the check mark for the log mode right here to get the exact value, right? So is right here, right? Now question B. In 2009, the United States had a per person income of $41,256.10 and a life expectancy is going to be 79.43 years. What is the result of this data using the model found in part A, right? So we know that the result is going to be actual value subtract the predicted value, right? So this one is the actual value, right? It's going to be 79.43. Now we need to find the predicted values. Given the income, it's going to be $41,256.10, right? Now look at the table right here. Make sure the income is counted at 1,000, right? So you need to convert each one to decimal. So it could be 41.256, right? So it could be L of 41.25610, right? Now you're gonna bring up the calculator right here. Previously, you're gonna save your equation as F2, right? So now I need to hit Control I. I need to add calculator and I just hit F2. Alright, so remember whatever equation you save, you need to memorize that one, right? So I have F right here, 2. Parentheses, I hit 41.25610. Alright, so I hit enter. The answer is 81.1181, right? So it could be 79.43 subtract 81.1181, right? Alright, so I need to subtract this one from 79.43 and the answer must be negative 1.68815, right? Now you can use TI-84 plus CE calculator, right? Previously, you saved your equation as y1, right? Now you just hit vars function y1, right? You hit parentheses and you hit 41.256 and you hit enter. It's gonna be right here, right? And you subtract it from 79.43, right? It's gonna be right here. So negative 1.68, right? Now if you use that mode, you need to copy this equation into the new line right here, right? So I have f of s. I just hit f of 41.256, right? And I hit enter. It's gonna be 81 right here, right? Now question C, a given country has an average income of $43,500. According to the model found in part A, what is the average life expectancy of an individual from this country? Alright, so you just use this one right here. Now you just bring up the calculator. You just hit F2 again, right? Hit parentheses and you just hit 43.5, right? And hit enter. It's gonna be 81.4642 years, right? So now let's move on to question number 14. Question number 14 is similar to question number 12. Alright, so I'm gonna leave this one for you to practice. I'm gonna give you the key, right? So the key right here, A equals 570 and B equals negative 65.2401, right? Now let's move on to part 3, calculators active, right? Now number 15, plot the following points on the same coordinate plane above. So this is semi-log plus, right? Now point A has the coordinate 0, 30, right? So x equals 0, y equals 30, right? So you know that this is 10 and this is 20 and this guy is 30, right? So point A is right here. Alright, point B, 1, 2. So this is 1 and 2 right here, right? The y-axis 1 and this guy 2, 3, 4, 5, something like that, all the way to 10, right? So 1, 2 should be right here. This is point B. Now point C, 2, 400, right? So 2 right here, 400. This is 100, 200, 300, 400. So it could be right here. This is point C. Now point D, 3, 1.5. So 3 right here, and this is 1. This is 2, 1.5 should be half of this one. So this could be right here. This is D, right? Now E, 4, 11. This is 4 and this is 10 right here and this is 20, right? So 11 should be above 10 a little bit. So it could be right here, right? So this is E. Now let's move on to number 16. The grid above is a semi-log plot with the vertical axis logarithmically scaled. Plot the following points on the same coordinate plane above. Now, point A, 0, 2, right? So 0, this is 1, this is 3, this is 2 right here, right? So this is point A. Now, point B, 10, 18, this is 10 right here. Now, 18 is going to be right here, right? This is point B. Now, point C, 20, 6, this is 20, this is 3, this is 6, 6 should be right here, right? Now, point D, 30, 12. 30 right here and 12 right here. This is 3, this is 9, right? Right? So this guy should be D. Now 40, 1.5, so it could be right here, right? Now number 17, the function f is graphed on the semi-log plot above, where the vertical axis has been logarithmically scaled. Which of the following function could be a model of f, right? Alright, so now first we need to connect this guy. And observe that this guy is a linear function, right? So we need to check to see if this guy right here a linear function, right? In the y-axis is logarithmically scale, right? So we're gonna take natural log both sides, right? So I have natural log of f of s equals natural log of 2 plus e times s, right? It turns out to be y equals natural log of 2 plus e times s, right? So this one is the logarithmic function, right? This is not a linear function, so a is wrong. Now b, take natural log both sides, so I have natural log of f of s equals natural log of 2 plus e to the s, right? So this guy turns out to be y equals natural log of 2 plus e to the s, right? This one is the logarithmic function. This is not a linear, so b is wrong. Now see, natural log of f of s equals natural log of 2 times e to the s, right? So I'm going to use the product rule, so I'm going to expand this one, right? So it could be natural log of 2 plus natural log of e to the s, right? Now I can bring s to the front, so it turns out to be y equals natural log of 2 plus s natural log of e, right? So I can rearrange this one. It's going to be natural log of e times s plus natural log of 2, right? So it's the same thing as ms plus b, right? Where m equals natural log of e and b equals natural log of 2. They're both constant, right? So this is a linear function, so the answer must be C. Now we can check the last one. It's going to be natural log of f of s equals natural log of 2 times e raised to the negative s, right? So it's going to be y equals, use the product rule, expand this one. So it could be natural log of 2 times plus natural log of e raised to the negative s. Bring this one to the front. So it turns out to be natural log of 2 minus s natural log of e, right? So this guy turns out to be natural log of e times s right here. Don't forget the negative side right here. Plus natural log of 2, right? So it's going to be negative ms plus b, right? The slope is negative, right? Which means the graph going down like this, right? But you look at the graph right here, it's going up, right? So this one is not the right answer, right? Now let's move on to number 18. A set of data is shown on the semi-log plot above. If an exponential regression is used to model this data, which of the following claim and explanation statements best fits this data? Alright, so go back to number 17 right here. If an exponential regression is used to model this data, the line should be straight line, right? It should be linear, right? Now, you look at this one, it's not a straight line. It's a curve, right? So answer choice A. The restore plot will show a clear pattern. Because the exponential model was appropriate. No. The exponential was not appropriate, right? Because it's a curve, right? So answer choice A is wrong. The restore plot will show no clear pattern because the exponential model was appropriate. So this is wrong, right? Answer choice C. The restore plot will show a clear pattern because exponential model was not appropriate. This is right, right? D. The restore plot will show no clear pattern because the exponential model was not appropriate. Right? This one must be clear, right? So this is wrong. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand